There are places in Australia where the ground opens and the dark below is not the dark of an ordinary cave. It is a different kind of dark, older, more complete. A dark that has been sitting in the same place since before the continent existed in the shape it exists in now, before the seas rose to their current levels, before the megafauna walked the red plains, before the first human foot touched Australian soil. A dark that has been accumulating in the chambers and tunnels and passages beneath the surface for so long that the word old stops being adequate and you need other words, geological words, words that measure time in millions of years rather than thousands. Australia is one of the oldest land masses on Earth. Its geological core, the craton that underlies much of the western and central parts of the continent, is more than 3 billion years old. 3 billion years of rock sitting in place, being worn down by wind and water and the patient work of time, its surface changing while its depth remains largely fixed, accumulating within its structure a record of conditions so ancient that the biology of the time is almost unrecognizable from the perspective of the present. And within that rock, in the chambers and voids and passages created by water and volcanic activity and the slow dissolving of soluble minerals over millions of years, there are underground spaces that have been isolated from the surface world for timescales that exceed the entirety of complex animal life on Earth. What lives in those spaces? What existed in them before humans ever arrived in Australia? What processes shaped them and what they contain today is a story that geology and biology and archaeology are still working to tell. Parts of it are extraordinary, parts of it are deeply strange, and a few parts of it have no satisfying explanation yet, which is where the most interesting questions live. This is not a story about human construction. The underground sites of Australia that we are going to visit tonight were not made by human hands. They were made by water and time and heat and the slow chemical conversation between rock and what moves through it. They were shaped by geological forces operating across timescales that make human history look like a single afternoon in a very long week. And yet they contain evidence of life, of process, of activity that raises questions that the standard narrative of Australian natural history does not fully answer. If you are watching this to fall asleep, that is exactly why I make these videos. Maybe subscribe and let me know where you are right now and what time it is. Someone is in a dark room in Sydney with the fan going and the traffic faint outside the window. Someone is in a tent somewhere in the Australian bush with a phone screen glowing in the dark and the sounds of the night pressing in from outside. Someone is nowhere near Australia at all, in a cold northern hemisphere city, lying under heavy covers, drifting towards sleep in a place as far from the red center as it is possible to be, and yet about to go underground in the oldest continent on Earth. That reach across geography and time is something I find genuinely moving. We are all in the dark together. We are all going down. So let the light go. Let your body settle into whatever holds it tonight. Let the surface world recede and let the underground begin. The first thing you need to understand about Australia's underground is that it is not a unified thing. It is not one cave system or one geological formation or one set of connected tunnels spreading beneath the continent like the root system of a vast tree. It is a collection of separate environments, each shaped by different geological processes, each isolated from the others in ways that have allowed them to develop their own distinct biology and chemistry and character over millions of years. But certain things connect them, a particular quality of darkness. A temperature that does not change with the seasons. An atmosphere that has not been mixed with the surface atmosphere for so long that its chemical composition has drifted away from what we breathe on the surface. And a silence that is not merely the absence of sound, but the presence of something that has been listening for a very long time and has no particular interest in what you have to say. We are going to visit several of these places tonight, not all of them. There are too many, and some of them are known only to the researchers who have spent years working in them, or to the Aboriginal communities whose traditional relationship with the land extends below the surface as well as across it, or to the animals and microorganisms that have been there so long they have become something the surface world would not recognize, but enough of them to understand what is down there and why it matters, and why the question of who made these spaces, or what made them, and what lives in them and has lived in them, is one of the most interesting questions in Australian natural science. The Nullarbor Plain sits across the southern edge of Australia like a sentence that refuses to end. It stretches roughly 2,000 kilometers from east to west and several hundred kilometers from north to south. A flat, treeless limestone plateau that was once the floor of a shallow sea. The name comes from the Latin for no tree, and the name is accurate. From the edge of the plain, in every direction, there is horizon and limestone and the salt bush and the bleached grass and the sky, enormous and pale and uninterested. Beneath the Nullarbor, there is a different world. The limestone of the plain is riddled with caves, not small caves, not the kind of cave you might find in a roadside attraction with handrails and electric lighting, and a tour guide making jokes about stalactites and stalagmites. The caves beneath the Nullarbor are vast. Some of them are flooded with water that has not seen the surface in tens of thousands of years. Some of them have chambers the size of aircraft hangars, their ceilings lost in darkness above the reach of any light a human carries. Some of them connect to other chambers through passages that require specialized equipment and considerable willingness to encounter the uncomfortable to navigate. The Cocklebiddy Cave System is one of the longest known underwater cave systems in the world. Divers exploring it have penetrated more than 6 kilometers from the entrance into passages that are completely submerged, navigating through a darkness so total that if their lights were to fail, they would have no sensory information at all to orient themselves. No up or down, no sense of movement, no reference point of any kind. The water in these passages is ancient. Its chemistry suggests it has been in the cave system for a very long time, cycling through the limestone at a pace too slow to track against the scale of a human lifetime. What lives in the water of Cocklebiddy and the other flooded cave systems of the Nullarbor is part of what makes these places scientifically extraordinary. The fauna of Australian Ankyline caves, cave systems that have some connection to the sea but whose water is not directly marine, includes animals that are found nowhere else on Earth. Crustaceans that evolved in isolation over millions of years. Their ancestors trapped the cave system as the sea retreated and the limestone plain formed above them, cut off from the surface world and from the sea. Adapting over geological time to the conditions of permanent darkness and the chemistry of ancient water. These animals are not recent arrivals. They did not wander into the caves and decide to stay. They are the descendants of marine organisms that lived in the shallow sea that covered the Nullarbor before it was the Nullarbor, before the sea retreated and the plain emerged from the water, before any human being existed anywhere on Earth. They have been in the dark for millions of years. They are the oldest residents of the Australian underground by a margin that makes every other claimant irrelevant. When biologists first discovered some of these cave-adapted crustaceans and brought them to the surface for study, they found animals that bore the marks of their long isolation in forms that are still being understood. Reduced or absent eyes, because in permanent darkness, eyes are not just unnecessary but metabolically expensive, a cost with no return. Elongated appendages, because in a world without vision, the sense of touch and the detection of vibration and chemical signals become the primary means of navigating and finding food. Metabolic rates so low that the animals can survive on the sparse organic material that filters into the cave system from the surface at a pace that would starve any surface-dwelling creature within days. They are exquisitely adapted. They are the products of millions of years of selection pressure in one of the most extreme environments on Earth. And they are alive down there in the dark water of the Nullarbor caves, going about their business with the complete indifference of creatures that have been doing this long before anything above them existed in a form they would recognize. But the biology of the Nullarbor caves is only one part of the story. The geology is another. The limestone of the Nullarbor was deposited between 35 and 15 million years ago, during the Eocene and Miocene epochs, when a warm, shallow sea covered the area. As the sea retreated and the land rose, the limestone was exposed to the slow work of water moving through it, dissolving the calcium carbonate grain by grain over millions of years, creating first small passages and then larger ones, and finally the vast chambers and connected tunnels that the caves contain today. The process continues. The caves are still growing, still being shaped by the water that moves through them, still accumulating the speleothems, the stalactites and stalagmites and flowstones and cave pearls and other mineral formations that record the history of water movement through the cave in a form that geologists can read like a text. That text is extraordinarily detailed. A stalactite growing in a cave on the Nullarbor is adding material to itself at a rate determined by the amount of water moving through the limestone above it, the temperature of the cave, and the chemistry of the water. Those factors are in turn determined by the climate on the surface. A dry period on the surface means less water reaching the cave, a slower growth rate, a layer of different composition in the stalactite structure. A wetter period means more water, faster growth, a different layer. Over thousands and tens of thousands of years, the stalactite accumulates a record of the climate above it, a record that geologists can read by slicing the stalactite and analyzing its layers. The stalactites of the Nullarbor caves contain climate records extending back more than 500,000 years. They show ice ages and interglacial periods, wet phases and dry phases, the long oscillations of Earth's climate through geological time. They show conditions that prevailed before any human being walked any part of Australia, conditions that shaped the environment into which the first Australians arrived, conditions that changed around them as they established themselves across the continent. The caves hold a memory of the world above them. They are a library of time written in mineral. Let that thought settle as the darkness deepens around you. A library of time, the stalactites of the Nullarbor hanging from the ceilings of their lightless chambers, writing the history of the surface world in layers of mineral deposited grain by grain over hundreds of thousands of years, requiring no reader, no archivist, no one to keep the knowledge. just the slow accumulation of record in the dark. Now, let's go somewhere different, somewhere the geology changes completely and the underground takes on a different character. The volcanic regions of southeastern Australia are not as old as the Nullarbor limestone. The volcanoes that created them were active until very recently in geological time. The most recent eruptions occurring only a few thousand years ago, close enough that the Aboriginal peoples of the region witnessed them and encoded the memory of the eruptions in their oral traditions, as we discussed in a previous story. But the lava tubes that the volcanic activity created are their own kind of underground world, different from the cave systems of the Nullarbor in their origin and their character, but sharing with them the quality of darkness and isolation that makes underground environments so distinctive. A lava tube forms when the outer surface of a flowing lava stream cools and solidifies, while the interior lava continues to flow. The solidified crust acts as insulation, keeping the interior hot enough to remain liquid. As the eruption continues and then ends, the liquid lava drains from the interior of the solidified crust, leaving behind a hollow tube, a tunnel of rock whose walls are the cooled outer surface of what was once a river of fire. The lava tubes of the Mount Gambier volcanic region in South Australia are among the most well documented in Australia, but they are not the only ones. The volcanic plains of Western Victoria contain lava tube systems that have not been fully mapped. The Undara Volcanic National Park in northern Queensland contains one of the longest lava tube systems in the world, tubes extending for more than 160 kilometers through a landscape of tropical woodland and grassland, most of it hidden beneath the surface, entered only through the occasional collapse of a tube roof that has created a skylight into the underground. The Undara tubes are not particularly old. The eruptions that created them occurred approximately 190,000 years ago, which in geological terms is recent, but in human terms is so long before any written record that it might as well be forever. The tubes have been cooling and stabilizing ever since. Their walls are dark basalt, the same rock that formed the surface lava flows, and their floors accumulate the debris that falls through the skylights, organic material from the surface above, animal bones, the remains of creatures that entered through the openings and could not leave. And in the Undara tubes, as in many of Australia's lava tubes, there is a distinctive ecology. The immediate vicinity of the skylights supports a forest of plants able to grow into partial light that enters through the opening. Bats roost in the tubes in large numbers, leaving through the skylights at dusk to feed on the insects of the surrounding woodland and returning before dawn, their guano accumulating on the tube floors and supporting a community of invertebrates that live entirely on the chemical energy it provides. But further into the tubes, beyond the reach of even indirect light, the ecology changes. The animals that live in the deep sections of the Undara tubes are not surface animals that have wandered in. They are cave-adapted species, some of them found only in the tubes themselves, small pale invertebrates that have been in the dark long enough to have begun the process of losing their pigmentation in their eyes, beginning the journey that the Nullarbor crustaceans have already completed, moving along the path from surface organism to cave organism that takes millions of years and requires the complete isolation of the population from the surface world. The Undara tubes are an ecological experiment in progress. They are showing in real time on a geological scale what happens when a population of surface organisms is trapped in the dark and cut off from the gene flow that connects it to its surface relatives. They are showing the first steps of a process that, given enough time, will produce organisms as strange and as exquisitely adapted as the crustaceans of the Nullarbor caves. The world below the surface is not static. It is not a museum piece. It is an environment with its own ecology, its own evolutionary dynamics, its own version of the same processes that shape the surface world. It just operates on a different timescale. The urgency of the surface world, the daily competition for food and mates and territory, the seasonal shifts, the rapid response to changing conditions, gives way underground to a different rhythm, slower, more patient, operating across thousands and millions of years rather than days and seasons. That slowing of time is something you can feel lying in the dark as the voice carries you through these underground places. Your own body has slowed, your breathing has found its nighttime pace. The urgent rhythm of the surface world has receded, and something older and more patient has taken over. You are not in a cave, but you're in the dark, and the dark has its own kind of depth. Now let's go to somewhere that is genuinely strange. To a place where the underground of Australia has produced something that does not fit neatly into the categories of geology or biology or archaeology, but sits uncomfortably in the space between them, requiring careful attention and a willingness to sit with uncertainty. The karst country of the Nullarbor is not the only limestone landscape in Australia that contains significant cave systems. The Margaret River region of Western Australia, the Narracourt Caves of South Australia, the Jenolan Caves of New South Wales, the Buchan Caves of Victoria, the Chillago Caves of Queensland, all of these and many more represent the karst landscapes that are distributed across the continent wherever suitable limestone exists. Each of them has its own character, its own geological history, its own biology, but there is a cave system in a remote section of one of Australia's karst regions that has become the focus of a quiet but serious scientific conversation. A conversation that involves geologists and biologists and archaeologists and increasingly the Aboriginal traditional custodians of the country above the cave. The cave system in question contains formations that do not have a simple geological explanation. Not the speleothems, not the stalactites and stalagmites, which are thoroughly understood and follow the chemistry of calcium carbonate precipitation in predictable ways. Not the cave pearls or the moon milk or the helictites, which are all unusual formations, but ones for which the geological mechanisms are established. The formations that have no simple geological explanation are different. They are layered, they are regular in a way that geological processes do not typically produce. They occur in specific parts of the cave, in locations that are not obviously correlated with the water flow patterns that drive most cave formation. And they contain chemical signatures that suggest they were deposited under conditions different from those that produce the surrounding rock. The scientists who have examined these formations have not made dramatic claims. They have done what scientists are supposed to do. They have documented the formations carefully. They have collected samples and subjected them to analysis. They have looked for geological explanations and found some that partially account for some of the observed features. And they have noted in their technical reports that certain aspects of the formations remain unexplained by the current models. That is where the story sits right now, in the careful language of scientific uncertainty, in the space between what is known and what needs more research, in the patient accumulation of data that will eventually tell a clearer story, though that story will not be told tonight and may not be told for many years. But the existence of that uncertainty, the fact that there are features in the Australian underground that have not yet been explained, is itself significant. It means that the story of what is down there is not finished. It means that the oldest continent on Earth still has surprises below the surface. Things that the science of the surface world is still developing the tools to understand. Your breathing is very slow now. The story is carrying you gently through a dark that is not threatening but is vast and very old and utterly indifferent to the passage of human time. The night is deep wherever you are. The surface world is quiet. And somewhere below the surface of Australia, in the limestone chambers of the Nullarbor and the lava tubes of Undara and the karst caves of Margaret River and the dozens of other underground systems distributed across the oldest continent on Earth, the deep dark is doing what it has always done, sitting still, listening to the slow chemistry of rock and water, housing organisms that have not seen light in millions of years, accumulating the layered record of time in its mineral formations, being old in a way that the surface world can barely imagine. The Narracoorta caves in South Australia are different again. They are not primarily known for their biology or their unusual formations. They are known for what is in their floors. The Narracoorta caves are World Heritage listed, and the reason for their listing is paleontological. Their floors contain the most complete and extensive record of Australian megafauna extinction of any site on the continent. The bones of the giant animals that once walked Australia, the Diprotodon and the giant wombats and the marsupial lions and the giant kangaroos and the many other large species that disappeared sometime in the period following human arrival in Australia, have been accumulating in the cave floors for hundreds of thousands of years. The accumulation happened through pitfall trapping. Certain openings in the cave floor, particularly in the fossil cave, were positioned and shaped in such a way that animals moving across the surface above were at risk of falling through. The light patterns around the opening may have been such that the opening was not clearly visible to an approaching animal. The opening led to a vertical drop into darkness. Animals fell in, they could not get out. They died, their bones accumulated in the cave floor, layer by layer, generation by generation, for hundreds of thousands of years. The record that accumulated is extraordinary. It is a time series of the fauna that lived above the cave across an enormous span of time, showing the presence and abundance of different species across different periods, and most significantly, showing the moment of disappearance of the megafauna, the transition from a fauna that included dozens of large species to the impoverished fauna of the present, where most of the large animals are gone and only a few species survive. The Narracoorta record is one of the key pieces of evidence in the ongoing scientific debate about why the megafauna disappeared. Were they hunted to extinction by the first Australians? Were they killed by the climate changes that accompanied the end of the last ice age? Was it a combination of factors? The bones in the cave floor carry isotopic signatures that tell researchers about the diet of the animals and the climate conditions during their lives. The stratigraphic position of the bones tells researchers about the timing of different species' disappearances. The Narracoorta cave floors are a document written in bone about one of the most significant ecological events in Australia's recent natural history. but not in human timescales. The Naracoorta record extends back more than 500,000 years, to a time when Australia's fauna was dramatically different from its current form, when the species that would eventually disappear were at the peak of their diversity and abundance, when the caves were filling with the bones of animals that had no awareness of the long record they were contributing to. The caves did not choose to be a record, they simply were what they were, a trap for unlucky animals. And though bones accumulated because there was nowhere for them to go, the cave did not intend to tell a story. But it tells one anyway, in the most durable medium available, in the language that geology has been speaking since long before biology arrived. Let yourself be in the Naracoorta cave for a moment in your imagination. The fossil floor is thick and dark and composed of the accumulated bones of hundreds of thousands of animals that fell through a hole in the surface world. The ceiling is low in some sections, high in others. The air is cold and still and carries the mineral smell of old stone and old time. There is no light. There has been no natural light in most of the cave for longer than any human civilization has existed. And below you, in the floor, in layers that go down for meters, the bones of a world that no longer exists are perfectly preserved in the dark. Sleep carries you gently now, as the dark of the cave becomes the dark of your own closed eyes, as the mineral smell becomes the smell of the room around you, as the cold of the cave becomes the warmth of the covers. Let the bones of the Naracoorta cave rest in their dark. They have been resting there for hundreds of thousands of years. They are very good at it. The underground of Australia has more to offer. There are places we haven't visited yet. Places where the story gets stranger and harder to explain in the comfortable categories of established science. The Kimberley region of Western Australia is primarily known for its surface landscape. The ancient sandstone escarpments, the extraordinary rock art, the dramatic tidal rivers and coastal formations. But beneath the Kimberley's surface, there are cave systems that have been explored only partially, that are known to be significant but whose full extent and character have not yet been mapped. The geology of the Kimberley is complex, with multiple rock types of different ages creating multiple opportunities for cave formation through different mechanisms. In certain sections of the Kimberley, there are cave entrances that the Aboriginal traditional custodians of the area have known about for a very long time. These entrances are not the subject of tourist infrastructure or academic publications in most cases. They are known to the people whose country they are part of, and they are significant to those people in ways that go beyond the biological or the geological. The relationship of Aboriginal Australian cultures to underground spaces is not well documented in the mainstream scientific literature, partly because the knowledge held by traditional communities about these spaces is held carefully and not freely shared with outside researchers, and partly because the scientific tradition has historically been more interested in the surface archaeology and rock art than in what lies below. But where researchers have been invited to engage with traditional knowledge about underground sites, the picture that emerges is consistent and interesting. The caves and underground spaces of the Australian landscape are not simply geological features to the people whose traditional connection to that country extends to its underground dimensions. They are significant places, places that have specific relationships with the stories of the dreaming, places that are understood as entrances to dimensions of reality that are not accessible from the surface, places that require specific protocols to approach and enter. This is not unique to Australia. The relationship of human cultures to underground spaces is ancient and widespread. The ritual use of caves extends back more than 40,000 years in the archaeological record, as we know from the cave art of Europe and from the evidence of ceremonial use of caves in many other parts of the world. The experience of entering a cave and moving from the world of light to the world of permanent dark has consistently, across many cultures and many periods of history, been understood as a transition between different modes of reality, a movement from the ordinary world to something deeper and more fundamental. That understanding does not require a literal belief in spirits or supernatural entities to make sense. The experience of being in complete and total darkness, of losing the sensory information that the surface world provides in overwhelming abundance, is genuinely transformative. The brain, deprived of visual input, begins to generate its own imagery. The deep silence of a cave, broken only by the sound of dripping water and the movement of your own body, produces a quality of attention that is difficult to achieve on the surface. The cold and the stillness and the darkness create conditions that are physiologically different from the surface conditions the human nervous system evolved to navigate. Something happens to consciousness in those conditions. It is not supernatural, it is neurological, but it is real and it is profound. And the people who have been exploring Australian caves for thousands of years for ceremonial and practical and knowledge gathering purposes have understood and worked with what happens to consciousness in the underground. The cave art that is found in some Australian caves, distinct from the rock art of open sandstone shelters and overhangs that is more widely known, suggests that the underground was used for specific kinds of ceremony that required the particular conditions only the cave could provide: the complete darkness, the isolation from the surface world, the altered state of consciousness that prolonged exposure to those conditions produces. This art is not widely published. Its locations are not publicly disclosed, both because the traditional custodians of the land maintain appropriate control over who knows about it, and because cave art is extremely vulnerable to damage from the carbon dioxide and moisture that human visitors introduce, and its preservation requires limiting access. But it exists. In the underground of Australia, in the deep sections of caves that are not accessible to casual visitors, there are images made by human hands that have been in the dark for a very long time. Longer, in some cases, than the cave art of Europe that is more widely known and studied. The darkness held them. The darkness preserved them. The darkness kept them exactly as they were left, unchanged by the light and weather that would have erased them on the surface. The underground of Australia is full of things it has been keeping: the bones of extinct animals, the climate record of hundreds of thousands of years, the isolated descendants of ancient marine creatures, the art of people whose relationship with the land extended below its surface. Let your mind rest in all of that keeping, the patient, indifferent preservation of the underground. The dark that does not choose to remember but remembers anyway, because nothing is lost down there. Your own dark is comfortable and warm and close. The underground of Australia is far away and cold and ancient, but both are dark, and in the dark the distances compress. You are not so far from those limestone chambers and lava tubes and karst passages. The dark connects everything. Sleep is very close now. But the story has a few more things to say. The most recently discovered of Australia's significant underground environments are not caves in the traditional sense. They are the voids and chambers beneath ancient lava fields, deep within the basalt of regions that were volcanically active in the relatively recent geological past, where the combination of lava tube formation and subsequent geological process has created environments that are functionally similar to conventional caves, but whose origin is different and whose biology, in some cases, has turned out to be startling. In 2023, researchers working in one of Australia's volcanic regions, a region that I will not name precisely because the location of the site is being kept out of public knowledge while assessment continues, discovered a series of interconnected chambers beneath a basalt plain. The chambers are accessible through a naturally formed entrance that is not visible from more than a few meters away. They extend for several hundred meters in total, branching in multiple directions, their floors covered in a material that is not the bare basalt of the walls and ceilings. The floor material is biological. It is a thick, layered accumulation of organic material that shows the chemical signatures of microbial activity. Communities of microorganisms living in the complete absence of light, extracting the energy they need not from photosynthesis, which requires light, but from the chemistry of the rock itself. This is called chemolithotrophy, the use of inorganic chemical reactions as an energy source, and it is one of the most extreme and ancient metabolic strategies known. It is found in deep ocean hydrothermal vents, in the deep subsurface of oil fields, in the brine channels of Antarctic ice. It is found wherever there is chemical energy available in the absence of light, and the organisms that practice it are among the most ancient and most fundamental on Earth. They do not need the sun, they do not need the surface world. They need only the chemical gradients that rock and water create when they interact over geological time. The microbial communities found in the Australian volcanic chambers are, based on preliminary genetic analysis, distinctive. They include species that are not yet described in the scientific literature, that have not been found in any surface environment, that represent lineages of microorganism whose relationship to other known microorganisms suggests a very long period of isolation. They are, in the most literal sense, the product of an underground existence that began so long ago that the surface world above them has changed beyond recognition multiple times since their ancestors last had any connection to it. These are the things that were not built by humans, not the cave systems of the Nullarbor, carved by the patient work of ancient water through limestone deposited by a sea that no longer exists. Not the lava tubes of Ondara and the volcanic plains, shaped by rivers of fire that flowed before any human mind conceived of fire as a tool. Not the underground chambers of the microbial communities, whose formation was driven by forces entirely indifferent to the presence or absence of any organism capable of intentional construction. Australia's underground is a world that built itself. It built itself through the operation of geological and chemical and biological processes across timescales that have no meaningful human parallel. It has been going about its own business in the dark for longer than the concept of business could have existed, and it will continue to do so long after the concept has been forgotten. The question of who made it or what made it has a simple answer in terms of mechanism, geology and water and biology and time. But that simple answer opens into a complex of further questions about process and timescale and the nature of the environments that were created and the life that adapted to inhabit them. And those further questions are where the genuine fascination lives. What is it like to be an organism that has been in the dark for millions of years? What is it like to be the descendant of a creature that last saw the surface before the Australian landscape existed in its current form? What is it like to be one of the microbial communities in the volcanic chambers, extracting energy from the chemistry of ancient rock, indifferent to the sun above and the surface world it illuminates? We cannot answer those questions from the inside. We can only observe from the outside with the tools of biology and chemistry and geology and try to understand what the observation tells us about the nature of life and its capacity to persist in conditions that seem, from the comfortable perspective of the surface world, impossibly extreme. The underground of Australia is a reminder that the conditions we consider normal, the light, the warmth, the atmospheric chemistry, the biological complexity of the surface, are not the only conditions under which life is possible. They are the conditions under which we evolved, and we have consequently come to think of them as necessary. But the organisms in the Nullarbor caves and the Undara lava tubes and the volcanic chambers say otherwise. They have been making do with much less for much longer, and the diversity and vitality of their communities suggest that making do is not the right description. They are thriving by their own standards. They are doing exactly what they evolved to do, in exactly the environment they evolved to do it in. The underground of Australia is their world. The surface is ours. And between the two worlds, in the entrances and the skylights and the pitfall traps and the archaeological sites where the two worlds touch, there is a zone of encounter that has been significant for both the surface organisms that occasionally enter the underground and the underground organisms that occasionally have the surface brought to them. That zone of encounter is where much of the most interesting science is currently happening, where the biologists and the geologists and the archaeologists and the traditional knowledge holders are working slowly and carefully to understand the relationship between the surface world and the underground world, and what that relationship has been across the enormous span of time that both worlds have existed. The story is not finished. It will not be finished in our lifetimes. But the outlines are becoming clearer, and the outlines are extraordinary. Good night from the surface world, which is all the world most of us will ever know, but which is only the most recent and most visible layer of a much more complex and much more ancient whole. Good night from the underground, which is older and stranger and more patient than any surface story can fully convey. Good night from the organisms in the dark, the pale crustaceans in the Nullarbor water, and the microbial communities in the volcanic chambers and the cave-adapted invertebrates of the Undara tubes. All of them going about their slow business in the complete absence of the light that powers the world above them. Good night. The breath goes slow, the dark is complete. The underground of Australia waits in the deep patience of geological time. Good night. There is a lake in Western Australia that sits on the surface of the land and yet connects through a network of flooded passages in the limestone beneath it to a world that has been sealed from the surface for so long that the organisms living in it carry genetic signatures pointing to ancestors who lived in the Tethys Sea, an ancient ocean that closed when the tectonic plates rearranged themselves into roughly their current configuration, somewhere between 5 and 20 million years ago. The Tethys Sea no longer exists. The Mediterranean is its remnant, much reduced. But some of the creatures that lived in the shallow coastal waters of the Tethys found themselves stranded in groundwater systems as the sea retreated and the land rose and the connections between the ocean and the subsurface water were sealed. They have been in those groundwater systems ever since. They have been adapting to complete darkness and the chemistry of ancient water for longer than the Mediterranean has existed in its current form. And some of their descendants are in the flooded caves of Western Australia, having traveled with the water through the limestone that was once the floor of a different sea, finding a darkness that suited them, settling in for the long work of adapting. The Western Australian stygofauna, as scientists call the animals of the underground water environment, are among the most diverse in the world. Stygofauna is from the Greek Styx, the river of the underworld, and it is the right name for these organisms because they inhabit a world below the world, a water world in the dark beneath the land, connected to the surface only through the slow percolation of rainwater downward through the rock, and the occasional upwelling of groundwater into surface lakes and rivers. The diversity of Western Australian stygofauna reflects the age and complexity of the landscape. There are crustaceans in the groundwater of the Pilbara that belong to lineages not found anywhere else on Earth. There are flatworms and nematodes and bacteria whose nearest relatives are in cave systems on other continents, remnants of the biological connections that existed before the continents separated. There are isopods, small crustacean relatives of the familiar slater or pillbug of garden walls, that have been in the underground water of the Pilbara for so long that they have become pale and eyeless and specialized for a way of life that no surface isopod could sustain. The Pilbara is a region that has already appeared in this story in the context of its surface megaliths and its ancient rock art, but the Pilbara's underground is as extraordinary as its surface, perhaps more so. The iron-rich ancient rock of the Pilbara contains within its structure a water system that is not visible from above, a network of passages and voids and saturated zones where groundwater moves through the rock at a pace measurable in years and decades rather than hours and days. In that slow water, in the complete dark of the ancient rock, the stygofauna go about their business. They have no awareness of the mining operations on the surface above them. The iron ore that makes the Pilbara one of the most economically significant regions in Australia is extracted from the same rock that contains the groundwater system their ancestors have inhabited for millions of years. The relationship between mining and stygofauna in the Pilbara is one of the most significant conservation issues in Australian ecology, precisely because the organisms at risk are so poorly understood, so utterly irreplaceable, and so entirely invisible to anyone who is not specifically looking for them. You cannot see a stygofaunal community. You cannot visit it in any normal sense. You can pump groundwater from a borehole and filter it carefully and examine what you have collected under a microscope. And if you are lucky and the borehole has encountered an inhabited aquifer rather than a sterile one, you will find organisms that are genuinely astonishing in their strangeness and specificity. An isopod the size of a grain of rice with no eyes and legs, adapted for swimming through rock cracks. A flatworm with no pigmentation, its internal organs visible through its translucent body. A copepod crustacean of a lineage that is found nowhere else on Earth. A species that evolved here, in this specific aquifer, in this specific section of ancient Pilbara rock. To find a new species of organism anywhere is significant. To find a new species of organism in an environment that has been sealed from the surface world for millions of years is to encounter the result of an evolutionary experiment conducted in isolation for a period of time that is difficult to comprehend. What has happened to that lineage in the dark? What selective pressures have operated on it? What has it lost, and what has it gained in the process of adapting to an environment that has no light, no seasonal variation, no surface weather, no predators from above? The answers to those questions are being worked out painstakingly by researchers who spend their careers collecting and analyzing organisms that most people have never heard of from environments that most people never think about. The picture emerging from that work is one of extraordinary diversity, extraordinary age, and extraordinary specificity. The underground of Australia contains communities of organisms that evolved here, that exist nowhere else, that are the product of millions of years of isolation in the dark beneath the world's oldest continent. These are things that were not built by humans. They are the product of processes far older than humanity, shaped by forces that operated long before anything with a brain existed on Earth. But they are alive. They are metabolizing and reproducing and evolving. They are doing the things that living things do in their own way, in their own time, in the dark below the surface. That is something worth knowing about. It is something worth carrying with you into sleep. The Genelan Caves of New South Wales are perhaps the most visited cave system in Australia and one of the most visited cave systems in the world. They lie in the Blue Mountains, west of Sydney, in limestone that was deposited in a warm, shallow sea, somewhere between 400 and 340 million years ago. That makes the Genelan limestone significantly older than the Nullarbor limestone, older by a factor of 10, deposit in a time when the organisms living in the sea above the sediment were dramatically different from anything alive today. Before the evolution of reptiles, before the evolution of dinosaurs, before the evolution of any animal more complex than the fish and the invertebrates and the primitive plants of the Devonian period. The caves formed in that ancient limestone over a long period as water moved through it, dissolving the calcium carbonate and creating first passages and then chambers. The age of the cave formation is debated, but the most recent research suggests that the oldest parts of the system began forming more than 300 million years ago. If that is accurate, Genelan is among the oldest cave systems currently known in the world. 300 million years of cave formation. 300 million years of water moving through passages in limestone, depositing mineral formations, shaping the chambers and galleries that the tourist trails now wind through with electric lighting and concrete paths and the comfortable narration of experienced guides. 300 million years of dark before the lights were installed. The guided tours of the Genelan caves are genuinely spectacular. The mineral formations, the stalactites and stalagmites, and cave coral and shoals and helictites and flowstones represent an archive of 300 million years of water chemistry moving through ancient limestone. The colors come from trace minerals, iron producing oranges and reds and yellows, manganese producing blacks and purples, the almost pure white of formations that contain nothing but calcium carbonate. The shapes reflect the physics of dripping water and slow mineral precipitation over timescales that no human being can intuitively grasp. But beyond the tourist areas, in the sections of the Genelan system that are not open to the public, the caves continue. Researchers working in the less accessible sections have documented fauna that is not found in the show caves, organisms that have adapted to the conditions of the deeper, less disturbed parts of the system. The show caves, though remarkable as visual experiences, have been altered by the presence of visitors in ways that are subtle but biologically significant. The carbon dioxide from human respiration changes the cave atmosphere. The light, even when turned off between tours, changes the biology of surfaces it illuminates. The warmth of human bodies and the organic material brought in on clothing and skin creates a different ecological environment from the undisturbed deep cave. The undisturbed deep cave is where the biology becomes genuinely strange, where the organisms found have been in the dark for generations, long enough that the evolutionary changes accumulating in their populations have begun to show, where the stegofauna of the groundwater beneath the cave floor represent lineages whose isolation from the surface world may be measured in millions of years rather than thousands. Jenolan is ancient in its limestone, ancient in its formation, and ancient in its inhabitants. It is one of the places where the deep time of Australia manifests most clearly in forms that a human visitor can, with some effort and appropriate guidance, come close enough to observe. But it is in the undocumented, unsurveyed, unseen sections of the Australian underground that the deepest strangeness waits, in the cave systems that have not yet been entered by researchers, in the aquifer communities that have not yet been sampled, in the volcanic chambers whose extent and biology are still unknown, in the passages beneath the vast sections of the Australian interior that are geologically appropriate for cave formation, but have not yet had anyone with the resources and the expertise to find and explore them. Australia is a large continent, a very large continent, and it is very old. The combination of age and size and the geological diversity that age and size produce means that the underground of Australia almost certainly contains surprises that have not yet been encountered. Ecosystems that science has not yet described, cave systems that have not yet been mapped, communities of organisms whose existence has not yet been confirmed, records of geological and biological history stored in mineral formations, in chambers that no living thing with a brain has ever entered. The unknown underground of Australia is one of the last genuinely unexplored frontiers on Earth. Not in the dramatic sense of terra incognita on a surface map, but in the practical sense of environments that have not yet been assessed and biological communities that have not yet been documented. The technology to explore some of these environments, the drilling and sampling equipment needed to access deep aquifers, the remotely operated vehicles needed to explore flooded cave passages, the genetic sequencing technology needed to characterize the microbial communities of deep rock formations is only recently becoming sophisticated enough to make these investigations feasible. The next decade of research into Australia's underground will produce discoveries that we cannot yet anticipate, discoveries that will add to the picture of what is down there and how long it has been there, and what it means for our understanding of the capacity of life to persist in extreme environments across geological time. That is exciting in the way that all genuine scientific frontiers are exciting. Not with the excitement of entertainment, which is immediate and intense and quickly replaced by the next thing, but with the quiet excitement of understanding, the sense that what is down there, when it is finally brought to light in the form of data and descriptions and images, will change the way we think about the world and about what life is and what it can do. Your eyes are closed now, probably. The voice is very far away and very close at the same time. The underground of Australia is somewhere in the darkness of your closed eyes, enormous and old and full of organisms going about their patient business in the rock. Let it be there. Let the dark be the Nullarbor dark, and the Pilbara aquifer dark, and the Narracoorta cave dark, and the Jenolan deep dark all at once. A composite underground, everything that the oldest continent holds beneath its surface, all of it at once in the darkness behind your eyes. It is a strange and very large thing to hold, but the dark is good at holding large things. It has been doing it for a very long time. Now let's talk about what happened to the megafauna. The story of Australia's megafauna is not an underground story, but it is connected to the underground through the Narracoorta record, through the bones preserved in the cave floors, and through the other cave deposits across the continent that contain the bones of animals whose surface world no longer exists. The megafauna of Australia were extraordinary. Diprotodon optatum, the largest marsupial ever to have lived, was the size of a hippopotamus. It browsed the plains and woodlands of Australia for approximately 1.5 million years before disappearing somewhere around 45,000 years ago, roughly coinciding with the arrival of humans on the continent. Thylacoleo carnifex, the marsupial lion, was a predator of remarkable efficiency with a bite force per unit of body mass that exceeded any other known carnivore. Procoptodon goliath, the giant kangaroo, stood nearly 3 meters tall and weighed more than 200 kilograms. Genyornis newtoni, the giant bird, was taller than a human and weighed around 230 kilograms. Megalania prisca was a monitor lizard of a size that currently has no living analogue, potentially reaching 7 meters in length and perhaps 600 kilograms. These animals lived across Australia for millions of years. They shaped the ecology of the continent in ways that are still being understood. The plants of Australia evolved in a world with mega herbivores, browsers, and grazers of enormous size that kept the vegetation in a constant state of response to their feeding pressure. The predators of Australia evolved in a world with prey animals of extraordinary size and strength. The landscape was shaped by the passage of these animals and by the ongoing negotiation between their biology and the biology of the continent, and then they were gone. The disappearance of the megafauna is one of the most significant events in the recent geological history of Australia. Recent meaning within the last 50,000 years, which in geological terms is barely a moment but in human terms is so long ago that no written record captures it, and only archaeology and paleontology and the cave bone deposits can tell us what happened. The debate about the cause of the megafauna extinction has been running for decades and remains genuinely contested. The two main hypotheses are human hunting and climate change, and the evidence supports elements of both and does not definitively exclude either. The timing of the extinctions broadly correlates with human arrival in Australia, which suggests human activity as a contributing factor. But the evidence from the Narracoorta cave record and from other deposits suggests that some populations of megafauna were already declining before human arrival, and that the climate changes associated with the last glacial maximum also place significant pressure on large animals. What the caves tell us, specifically, is that the megafauna were present and apparently healthy in certain regions right up to a relatively brief period before their final disappearance. The Narracoorta record shows that the population of large animals using the caves as a pitfall trap was not declining gradually over a long period. It was present and then it was not, with a transition that in the cave record looks sudden, though sudden in this context means a period that may span thousands of years. The bones in the cave floors are not just a record of extinction. They are a record of the world that existed before the extinction, a world with animal communities so different from those of modern Australia that a visitor from the present would find the fauna utterly alien. A landscape where a marsupial hippopotamus browsed alongside animals recognizable as relatives of the modern kangaroos and wombats, where a marsupial lion ambushed prey from the trees, where a snake longer than any living Australian snake moved through the undergrowth, where enormous lizards competed with crocodilians for the largest prey in the river systems. That world is gone. Its absence is one of the defining facts of the Australian landscape that exists today. The ecology of modern Australia, impoverished of its large animals, is a consequence of what happened between 45 and 60,000 years ago, when the megafauna disappeared and the continent entered the ecological condition it has maintained ever since. The caves hold their bones. The dark holds the memory of the world that was. The lava tubes of the Carnarvon Gorge region in Queensland are a different kind of underground, less dramatic than the famous Undara tubes, but significant in their own way. Their ecology shaped by the specific geology of their formation and the climate of central Queensland. The gorge itself is a surface feature of extraordinary beauty, a narrow sandstone canyon cut by a creek over millions of years, its walls rising more than 200 meters above the creek bed, its floors covered in cycads and ferns, and the tracks of the many animals that use the gorge as a refuge in the surrounding dry woodland. Beneath the gorge, the geology is different from the surface sandstone. There are sections where basalt underlies the sandstone, remnants of volcanic activity that occurred in the region millions of years ago. And in those basalt sections, there are passages that connect to the surface through the creek bed and through the walls of the gorge. Some of those passages are known to the local Aboriginal communities, the Bidjara people, whose country includes the Carnarvon Gorge region. Some of them have been documented by cavers. Some of them are known only to the animals that use them. The animals that use the lava passages of the Carnarvon region are a mix of surface-adapted species, bats and possums and reptiles that move between the surface and the underground without the full adaptation to cave life, and a smaller community of genuinely cave-adapted organisms in the passages that are not accessible to surface light. The interaction between these two communities, the surface animals that use the caves opportunistically and the cave-adapted animals that have no other home, creates an ecological dynamic that is being studied in the context of the broader ecology of the gorge. But the most interesting biological inhabitants of the Carnarvon underground are not the visible animals. They are the microbial communities that live in the rock walls of the passages themselves, in the thin films of water that coat the surfaces, metabolizing the minerals of the basalt in the slow chemolithotrophic way that we encountered earlier in the volcanic chambers of southern Australia. These communities are extraordinary in their metabolic diversity. They include organisms capable of oxidizing iron, sulfur, manganese, and other minerals, extracting the small amounts of energy available in each oxidation reaction and building complex cellular structures from it. They include organisms capable of fixing nitrogen from the atmosphere that permeates through the rock, converting it into a biologically useful form. They include organisms whose metabolic pathways are so unusual that they do not fit neatly into any of the established categories of microbial ecology and represent biochemistry that is still being characterized. The rock of Australia's underground is not inert. It is alive with microbial metabolism, with the slow chemical reactions that extract energy from the minerals of the earth and use that energy to maintain the complex molecular machinery of living cells. This metabolic activity, invisible and undetectable without specialized analytical equipment, has been occurring in the Australian underground for as long as the rock has existed in its current form, which in some cases means billions of years. The oldest rocks in Australia contain evidence of microbial activity in the form of chemical signatures and microscopic structures that microbiologists interpret as fossils of the earliest living things. The Pilbara contains stromatolites, structures built by ancient cyanobacteria that are among the oldest confirmed evidence of life on Earth, dated to approximately 3.5 billion years ago. The microbial communities in the underground of the Pilbara today are therefore living in the shadow of one of the oldest known biological lineages on Earth, in rock whose formation they have been influencing since the beginning of life itself. 3.5 billion years of microbial activity in the Australian underground, not continuously in any one place, because the geological changes that have occurred over that time span have created and destroyed environments many times, but continuously in the sense that at every point in the last 3.5 billion years, there have been microbial communities in the Australian rock doing what microbial communities do, extracting energy from the chemistry of the earth and using it to stay alive. That is an incomprehensible span of time. It predates the evolution of photosynthesis. It predates the accumulation of oxygen in the atmosphere. It predates the evolution of any organism larger than a single cell. The story of life on Earth, which is ultimately the story of energy extraction from an environment and the use of that energy to build and replicate molecular complexity, began in environments that were not fundamentally different from the Australian underground of today. Dark and mineral rich and dependent on chemical energy rather than sunlight. The deep underground of Australia is not just a record of past life. It is a continuation of the oldest known life on Earth, conducted by organisms whose lineages extend back to the beginning of life itself, in environments that have maintained the basic character that made life possible while the world above transformed beyond recognition. You are being carried through very deep time now, the oldest time. The time before eyes, before brains, before movement, before anything recognizable as an organism to a casual observer. The time of the chemistry of rock and water and the thin margin between those two that life first learned to inhabit. Your own body is a product of that long history. The mitochondria in your cells, the organelles that produce the ATP that powers everything your body does, are the descendants of bacteria that learned to use oxygen as an energy source more than 1.5 billion years ago, before the evolution of any organism large enough to be visible to the naked eye. The deep chemical logic of your metabolism is ancient in a way that makes the human story look like a footnote. You are ancient. You are the current expression of processes that began in the dark, in the interface between rock and water, in the earliest environments that life learned to inhabit on this planet. The underground of Australia connects you to that beginning, not metaphorically, literally. The microorganisms in the basalt caves and the limestone aquifers and the ancient rock of the Pilbara are your relatives. Not close relatives, not in any way you would normally use the word family, but relatives in the way that all living things are related, sharing a common ancestor that lived in some primordial environment and survived long enough to reproduce, passing forward the molecular logic of life that eventually, through billions of generations of variation and selection, produced both the pale crustaceans of the Nullarbor caves and you. That is a remarkable thing to carry into sleep. Good night from the deep ancestry. Good night from the 3.5 billion-year-old lineage of life in the Australian underground. Good night from the organisms that have been in the dark longer than anything else alive on Earth. Good night. The breath slows, the dark deepens. The underground of Australia is vast and old and full of life going about its patient business. Good night. There is a particular phenomenon in Australian cave systems that researchers call the cave breath. It is not a metaphor. When the atmospheric pressure changes at the surface, whether because of the approach of a weather system or the daily thermal cycle of the surface air, the pressure difference between the surface and the inside of the cave causes air to move through the cave entrance. In one cycle, air moves into the cave. In the other, air moves out. The cave breathes. The cave breath carries surface air into the underground and carries underground air to the surface. It is a mechanism for mixing the atmosphere of the two worlds very slowly at the points where they connect. It brings oxygen into the cave and takes carbon dioxide out. It carries the chemical signatures of the surface world, the pollen and the dust and the organic molecules of the surface atmosphere, into the underground. And it carries the chemical signatures of the underground, the mineral-laden air that has been in contact with the cave surfaces for a very long time, out to the surface. If you stand at the entrance of a cave with a deep enough system behind it on a day when the pressure is dropping, you can feel this breath on your face. A cool, mineral-smelling exhalation from the earth. A breath from a body so large and so old that the metaphor of breathing seems inadequate, but is also somehow exactly right. The Aboriginal Australian traditions that regard significant cave entrances as the breathing openings of the earth itself are drawing on a physical reality that is also metaphorical. The caves do breathe. They exchange air with the surface world in a rhythm that follows the weather and the seasons and the daily cycle of temperature. They are connected to the surface atmosphere, though that connection is slow and the mixing is incomplete, and the underground retains its distinctive chemical character despite the exchange. This is part of what makes the cave entrances significant in Aboriginal Australian understanding. They are places where the underground and the surface world communicate. Where the underground world offers something of itself, the cool breath, the mineral smell, the darkness visible just inside the entrance, and takes something of the surface world into itself, the warmth and the light and the organic complexity of the surface atmosphere. The breath goes both ways. The exchange is mutual. The relationship between the two worlds is maintained through the breathing of the cave, the slow mixing of their atmospheres at the points of contact. Breathing is how you are still here, still in this story, still in the dark of your room or your tent or wherever the night has found you. The breath goes in and out. The oxygen from the surface atmosphere crosses into your blood. The carbon dioxide from your metabolism crosses back out. You're in constant exchange with the world around you, maintaining the chemical gradient that life requires, staying alive through the same basic process that the cave-adapted organisms use. The same process that the first living things on Earth discovered when they learned to extract energy from their environment and use it to persist. The cave breathes. You breathe. The underground and the surface world exchange their atmospheres at the cave entrance. The microorganisms in the rock walls exchange molecules with the thin films of water that coat them. Life, at every scale and in every environment, is exchange, is the maintenance of a difference between inside and outside, a gradient between the chemistry of the organism and the chemistry of the environment, a difference that is constantly being eroded by thermodynamics and constantly being renewed by metabolism. The cave keeps its inside different from its outside. You keep your inside different from your outside. Both of you are doing the same fundamental thing, maintaining the organized complexity of a living system against the tendency of the universe to move toward disorder. The universe is very old. The tendency toward disorder has been operating for a very long time. And yet, here you are, organized and complex and breathing in the dark, the current expression of a 3.5 billion year old refusal to simply dissolve into equilibrium. That is not a small thing. That is perhaps the most remarkable thing. Sleep now, extraordinary organism. The underground of Australia is enormous and old and full of other extraordinary organisms going about their own version of the same refusal. The dark holds all of you together, the surface sleepers and the cave dwellers, and the aquifer animals and the microbial communities in the ancient rock, all of you maintaining your organized complexity against the long drift toward disorder. Good night. The Chillagoe Caves in northern Queensland are formed in limestone of a different age and a different character from the Nullarbor or the Jenolan. The Chillagoe limestone was deposited in a reef system that existed in the Devonian period, roughly 400 million years ago, when the geography of the continent was entirely different and the organisms building the reef were not corals in the modern sense, but a community of reef builders whose diversity and abundance created rock that now forms the dramatic towers and spires of the Chillagoe landscape. The caves within the Chillagoe limestone are accessed through entrances in those towers, and inside the caves, the remains of the Devonian reef builders are visible in the cave walls. Fragments of the organisms that built the rock, preserved in the limestone over 400 million years. The cave is not just a cave, it is a sample of the Devonian ocean floor, with the biology of its reef preserved in the rock that the water has subsequently dissolved into chambers and passages. The Chillagoe caves are warm, warmer than many Australian cave systems because of their northern latitude and the character of the surrounding landscape. They are home to bat populations of significant size, whose guano provides the energy base for the cave ecosystem. They are also home to cave-adapted invertebrates, though the species complement is different from that of the southern cave systems because the isolation history and the geological context are different. What is consistent across all Australian cave systems, north and south, limestone and volcanic, flooded and dry, is the isolation. The isolation that allows the cave communities to develop their own biology over geological time. The isolation that keeps the underground world separate from the surface world in ways that allow it to become genuinely different, not just a darker version of the surface, but a different environment altogether, with its own rules and its own biology and its own version of what it means to be alive. That isolation is what produces the strangeness. The pale crustaceans and the eyeless fish and the microbial communities with their unusual biochemistry. The isolation of the underground from the surface, maintained over millions of years, allows the evolutionary experiment of cave life to run long enough to produce results that the surface world cannot produce. Organisms that have given up everything connected to light because light is not available and investing in the machinery to respond to it is metabolically expensive. Organisms that have enhanced every other sense and extended every other appendage, because in the absence of vision, the world must be navigated by touch and chemistry and vibration. Organisms that have slowed their metabolism to match the sparse energy resources of their environment, living at a pace that would read as barely alive by surface standards, but is perfectly suited to the conditions of the deep underground. The cave does something to the organisms that live in it over long enough periods of time. It simplifies them in some ways, stripping away the complexity that was relevant to the surface world and is no longer relevant. It complexifies them in other ways, enhancing capacities that were minor surface capabilities and making them the primary tools for survival. It produces organisms that are highly specific to their environment, exquisitely adapted to the cave and to nothing else, incapable of surviving on the surface where the light and the temperature variation and the predators and competitors they have no defenses against would quickly be fatal. This specificity is what makes the cave organism so vulnerable. The organism that has become perfectly adapted to a specific cave is also perfectly dependent on that cave. If the cave changes, if the hydrology changes and the water level drops or rises, if the organic input from the surface changes, if the temperature changes, if human activity alters the chemistry of the cave atmosphere or the water, the organism has no fallback. It cannot simply move to another cave because another cave will have different conditions that it is not adapted to. It cannot revert to surface life because the surface capabilities it had when its ancestors first entered the cave have been lost over millions of generations of no longer being needed. The conservation of cave organisms is therefore, in a very real sense, the conservation of specific environments. You cannot save a nullarbor cave crustacean by moving it to a different cave. You have to save the specific cave and the specific aquifer and the specific water chemistry that the specific crustacean has adapted to over millions of years. This is an extremely difficult conservation challenge. The caves and aquifers of Australia are not visually dramatic. They do not have the appeal of a whale or a quoll or a bilby. They are largely invisible and poorly understood and inhabited by organisms that are technically impressive but not photogenic. The conservation effort required to protect them competes with development pressures, with mining that pumps groundwater from aquifers and changes the hydrology of cave systems, with agriculture that introduces chemical contamination into the water table, with tourism that brings human visitors into cave atmospheres that the organisms living there did not evolve in the presence of. The work is being done slowly, with limited resources, by researchers who care deeply about organisms that most of the public has never heard of, by conservation advocates who try to translate the significance of these invisible communities into language that conveys why they matter to people who will never see them. They matter because they are irreplaceable. They matter because they are the product of processes that took millions of years and cannot be replicated on any human timescale. They matter because they are part of the story of life on Earth, a story that is much longer and much more varied and much more extraordinary than the surface world version of the story that we usually tell. They matter because the dark below the surface of Australia is not empty, it is full. Your dark is full too, full of the slow, quiet work of your body in sleep. The repair and the restoration and the consolidation of memory and the processing of the day's experience into the material of the self. The underground processes that your own biology carries out in the hours when consciousness is suspended are their own version of what the cave organisms do in the permanent night of the underground. Sleep is the cave of the body, the place where the ordinary functions of waking life are suspended and the deeper maintenance work goes on. The place where the chemistry of the self is renewed and the record of the day is sorted and stored. The place where the work that consciousness cannot see happens most efficiently in the dark, in the quiet, in the removal from the sensory complexity of the surface world. Good night from the cave of sleep. Good night from the biological dark that is doing its patient work in you even as the words fade. Good night from Australia's underground, vast and old and alive in ways that science is still learning to see. Good night. The deep night has qualities that are worth naming because naming them is part of understanding what they share with the underground environments we have been traveling through. There is a specific quality to the dark that is present when the hour is very late and the surface world is quiet and the conscious mind has let go of most of its daytime concerns. It is a dark that has texture to it. A dark that you can feel against your skin, slightly, in the difference between the air that moves and the air that does not, in the temperature gradient that exists between the surface of your body and the cooler air around it. A dark that has sound in it, the particular silence of the late hours, which is not silence at all, but the composite of all the sounds that the night produces. The settling of the building around you, the distant traffic, the movement of air through whatever passage connects the room you are in to the outside world. That dark, the dark of the late hours in whatever space you are inhabiting tonight, is a surface dark. It is bounded. You know that if you open your eyes or reach for a switch, light will come. You know that the morning is coming, that the surface world is going about its business even while you are withdrawn from it, that the dark is temporary. The dark of the Australian underground is not temporary. The dark 200 meters into the Nullarbor cave system is the same dark that was there 1,000 years ago, 10,000 years ago, 100,000 years ago. The organisms in that dark have been in it for so long that the concept of the dark being temporary, of light eventually returning, has no meaning in their biology or their behavior. They evolved in permanent dark. Their entire biology is built around the assumption that the dark is not a condition but a constant. That is a different relationship with darkness from any that surface organisms have. Even the most nocturnal surface creature has a biology built around the expectation that light will return, that there is a rhythm to the dark and the light, that the world alternates between conditions. The cave organisms have no such expectation. For them, the dark is simply what is, not a waiting period between bouts of light, not a problem to be survived until conditions improve. Just the condition of existence, permanent and complete, and the only condition in which their particular version of life has ever operated. Imagine what it would be like to inhabit that understanding. To be an organism for whom the question of light is simply not a question, for whom the concept of vision, of using light reflected from surfaces to build a model of the world, has been absent from the biological toolkit for so many generations that the capacity for it is not even a vestige but a memory so distant that even the genetic traces of it have largely been erased. The cave organisms do not live in darkness the way you live in a dark room. They live in darkness the way fish live in water. Completely, necessarily, without the awareness of any alternative. Your own dark tonight is full of alternatives, full of the awareness that light is available, that the morning is coming, that the dark is chosen. You chose to turn the lights off. You chose to listen to this voice in the dark. You could choose differently. The cave organisms have never had that choice. Something about that distinction is both humbling and comforting. Humbling because it makes the scale of cave adaptation visible, the millions of years required to produce organisms for whom the dark is not a condition but a constant. Comforting because your own dark is so bounded, so voluntary, so temporary. The morning is coming. The surface world is waiting. The dark tonight is borrowed, not permanent. Sleep in it. Let it be temporary and complete and comfortable. The cave organisms will be in their permanent dark long after your morning has come. The flooded cave systems of the Mount Gambier region in South Australia represent a different kind of underground ecology from the dry caves of the Nullarbor or the lava tubes of the volcanic regions. Mount Gambier sits above a limestone aquifer that is one of the most extensive in Australia, a vast reservoir of groundwater moving slowly through the porous limestone beneath the region's surface. The town itself is built on the rim of a dormant volcano, and the volcanic crater contains a lake whose water is one of the most intensely blue bodies of water on Earth. The Blue Valley Lake that is one of Mount Gambier's most visited natural features. The blue of the lake comes from the optical properties of the very pure limestone aquifer water that feeds it. The water contains almost no suspended particles. When sunlight penetrates it, the scattering of light at the blue end of the spectrum is not overwhelmed by the scattering produced by particles, so the blue wavelengths dominate, producing a color that has no convincing parallel in surface water systems with normal particle loads. Below the blue lake, below the limestone that contains the aquifer, there are flooded passages that extend for considerable distances through the rock. Cave divers have been exploring these passages since the 1970s, pushing into the underground water system through entrances in the lake bed and in nearby sinkholes, mapping passages that connect to each other and to the lake and to other surface water bodies in the region. The biology of the Mount Gambier flooded caves is distinctive. The water is extraordinarily clear, cold, and low in nutrients. The organisms that live in it are adapted to these conditions, which select strongly for metabolic efficiency, for the ability to find and process the sparse organic material that filters into the system from the surface, and for the behavioral and physiological adaptations that reduce metabolic cost in the absence of abundant energy. The cave divers who explore the Mount Gambier system work in conditions that have no surface parallel. The visibility in the water is sometimes measured in hundreds of meters, which for a cave diver is both extraordinary and disorienting, because the human visual system did not evolve to navigate spaces where you can see so far that the walls and ceiling of the passage are at the edge of visibility or beyond it. The absence of particles in the water also means the absence of the visual cues that surface water divers use to orient themselves. Without particles in the water to scatter the beam of the dive light, the beam does not create the cone of illuminated space that divers use to judge distance and direction. The passage can seem endless. The dark beyond the light's reach can seem to go on forever. For the organisms that live in this water, of course, the extraordinary clarity is irrelevant. They cannot see it. They navigate the passages by chemistry and touch and vibration, as cave organisms do. The fact that a human observer with a dive light can see for 200 meters in any direction is not information that the cave organisms can use. They live in the dark as they have always lived, and the dark is what it is, regardless of the optical properties of the water. The cave divers bring something the cave organisms have never encountered before: light. For the pale crustaceans and the cave-adapted fish and the other stygofauna of the Mount Gambier system, the appearance of a moving beam of light in their permanent dark would be as alien as the appearance of a whale in a suburban street. They have no behavioral response to it. They have no evolved instinct that tells them what light means or how to react to it. Their ancestors encountered light before they entered the cave system, but that was many millions of years ago, and the genes encoding a response to light have been slowly degraded since then by mutation and selection. The capacity to respond to light is an expensive molecular mechanism that provides no benefit in the dark, and expensive mechanisms that provide no benefit are gradually lost. So the cave divers move through the passages of the Mount Gambier system, surrounded by organisms that cannot see them, carrying in their lights a condition that has never existed in these passages before. And the organisms continue about their business as if the light were not there, because for them it might as well not be. That is a strange kind of encounter. Two worlds meeting in the dark water of an Australian limestone cave, each completely opaque to the other, each going about its own business with different assumptions about what the world is and what it contains. The cave divers look for new passages, new chambers, new biological communities. The cave organisms look for food, for mates, for the chemical gradients that tell them where in the passage system they are. Neither encounters the other in any meaningful sense, despite sharing the same dark water. The Australian underground is full of these non-encounters. Places where the human world and the underground world overlap physically without connecting. Caves that humans have entered but not understood. Aquifers that humans have sampled but not fully characterized. Rock formations that humans have observed but not yet explained. The overlap is real, but the connection is partial and provisional, limited by the tools and the time and the knowledge available to the researchers who have so far worked in these environments. The full connection, if it ever comes, will require many more years of research and many more tools and a level of understanding of cave ecology and cave geology and cave chemistry that is still being developed. It will require the ongoing collaboration of the scientific tradition with the traditional knowledge traditions of the Aboriginal communities, whose relationship with these underground environments extends across thousands of years, and whose knowledge of them is qualitatively different from what scientific research has so far produced. That collaboration is happening in some contexts, in some regions. It is slow and incomplete and complicated by the history of the relationship between scientific institutions and Aboriginal communities, a history that includes the extraction of knowledge and specimens without consent and the dismissal of traditional knowledge as not scientifically valid, and the exclusion of traditional custodians from decisions about the management of their own country. That history makes trust slow to build and easily damaged, but the collaboration is happening. And where it is happening, the picture of the Australian underground that emerges is richer and more nuanced and more complete than what either tradition produces on its own. the traditional ecological knowledge of Aboriginal Australians about underground environments includes practical knowledge, the locations of water sources accessible through cave systems, the seasonal variation in the cave breathing that indicates changes in surface conditions, the significance of specific cave entrances in the ceremonial geography of specific countries. It also includes what can be described as observational natural history, knowledge of the organisms found in cave systems and their behavior, and their significance in the broader ecology of the country. This knowledge is not held in written form. It is held in story and in ceremony and in the practical knowledge of living and traveling in country. It is held by individuals and communities with varying degrees of completeness, and the loss of that knowledge through the displacement of communities from their countries, through the deaths of knowledge holders before their knowledge was transmitted, through the disruption of the cultural practices that maintain the transmission of knowledge, has been significant. But what remains is significant too, and the process of working with remaining knowledge holders to document what they know about the underground environments of their countries is producing insights that would not be accessible through scientific research alone. The underground of Australia is a shared domain. It belongs to the rock and the water and the organisms that have been there for millions of years, and to the Aboriginal communities whose relationship with the country extends through the surface and into the underground, and to the researchers who are working to understand it, and to the broader human community that will need to make decisions about its conservation and management in the years ahead. It does not belong exclusively to any of these. It is a shared heritage in the deepest sense of that word, a part of what makes Australia Australia and what makes the world the world. Knowing it, even partially, even through the incomplete medium of a late night story told in the dark, is a form of participation in that shared heritage. You are participating now, wherever you are, whatever state you are in between waking and sleep. Good night from the shared underground. Good night. Now let's go somewhere that has not been mentioned yet. To the caves of the Buchan region in Victoria, where the limestone is Devonian like the Chillago limestone, but the geography is entirely different. The Buchan Cave, sitting in a narrow river valley in the foothills of the Victorian Alps, surrounded by forests that thickens as the altitude rises and the temperature drops. The Buchan Caves are famous among cavers and cave scientists in Australia for the quality and diversity of their speleothem formations. The stalactites and stalagmites of the Buchan Caves have been used as climate proxies, as records of past climate conditions that can be extracted by analyzing the layers of mineral deposited over thousands of years. The climate signal in the Buchan speleothems extends back beyond 100,000 years, capturing the full last glacial cycle and the warming that followed it, the conditions that prevailed while the megafauna were disappearing from the surface above, and while the first human communities were establishing themselves in the surrounding landscape. The Aboriginal communities of the Buchan region, the Gunai Kurnai people, have been in this country for a very long time. The surface archaeology of the region includes sites that date back many thousands of years, and the oral traditions of the Gunai include knowledge of the caves that is consistent with a relationship extending across many generations. The caves are part of the traditional territory and traditional knowledge of the Gunai in ways that go beyond the geological and biological. The cave entrances in the Buchan Valley are natural features of the limestone landscape, openings in the hillsides where water has dissolved away the rock and left passageways into the dark. The Gunai understanding of these openings, the significance attributed to them, the protocols associated with approaching them, reflects a tradition of relationship with underground spaces that parallels the traditions of Aboriginal communities in other parts of Australia, whose country also contains significant cave systems. The relationship is one of acknowledgement of the cave as a presence in the landscape rather than simply a geological feature, of the underground world as a dimension of the country that requires attention and respect, and the maintenance of appropriate relationships, just as the surface dimensions of the country do. This is not anthropomorphism. It is not the attribution of human qualities to geological features. It is something more subtle and more interesting. The understanding of the cave as embedded in a web of relationships that includes but extends beyond the purely physical, as significant in the ceremonial geography of the country and in the stories that explain the country as the rivers and the mountains and the significant trees of the surface landscape. The Buchan caves in that understanding are not simply holes in the ground with attractive mineral formations. They are part of what the country is, part of the full description of the landscape that the Gunai Kurnai tradition carries, part of the obligation of care that belongs with the custodianship of that country. That is a richer understanding than the geological one, though not incompatible with it. The geological description of the Buchan caves is complete and accurate as far as it goes. The limestone is Devonian. The cave formation began in the Permian period. The speleothems record climate across more than 100,000 years. The biology includes cave-adapted organisms of several different taxonomic groups. These facts are all true and all important. But the Gunai Kurnai description of the caves, which includes all of that and more, which includes the ceremonial significance and the relational obligations and the knowledge of the caves as part of a living landscape, rather than a static geological feature, is also true. And the combination of the two descriptions is closer to the full truth of what the Buchan caves are than either description alone. The full truth of Australia's underground is going to take a long time to arrive at. The geological truth is still being assembled by researchers who keep finding new cave systems and new biological communities and new climate records and new formations that challenge existing models. The traditional knowledge truth is being maintained by the communities that hold it, slowly being documented in the collaborative research that is happening in some regions, and still being lost in places where the disruption to traditional communities has been most severe. The full truth will be a synthesis. It will be the product of the conversation between scientific research and traditional knowledge that is slowly and imperfectly getting underway in Australia, the conversation that has already produced the recognition of Budgebim as World Heritage, and the inclusion of traditional knowledge in the management of significant sites across the country, and the growing acknowledgement in Australian archaeology and natural science of the depth and validity of Aboriginal knowledge traditions. That conversation is one of the most important conversations happening in Australian science and culture right now. It is happening underground in the most literal sense, in the joint assessments of cave systems and aquifer communities that bring together researchers and traditional knowledge holders. And it is happening on the surface in the academic and policy and cultural spaces where the implications of that collaboration are being worked through. You are in the middle of the night now, wherever you are. The conversation is still going on, even in the dark, even while you sleep. Somewhere in Australia, someone is thinking about the underground, or writing about it, or talking about it, or simply living in country where the underground is part of the landscape and the knowledge and the obligation. The underground of Australia does not sleep. It does not need to. It has its own version of rest, the geological timescale of very slow change, the metabolic timescale of the organisms that live in it, the centuries-long accumulation of mineral layers in the speleothems. But it does not have the sleep of consciousness, the withdrawal from the surface world into the dark of the body's own restoration. That is something only surface organisms have. The luxury of shutting down the conscious engagement with the world and letting the underground of the body do its work. You have that luxury tonight. Use it. Let the surface world be surface. Let the underground be underground. Let the dark of your room be the dark of your room, and the dark of the Australian cave systems be the dark of the Australian cave systems. Vast and ancient and full of organisms that have been in the dark so long, they have forgotten what light is. Let everything be what it is. And sleep. There is one more thing the story wants to say before the last words release you into the full dark. The Australian underground holds, in its depths, a record of what this continent has been across an enormous span of time. The oldest rock holds the oldest life. The limestone holds the climate record of the ice ages. The cave floors hold the bones of the megafauna. The aquifers hold the genetic signatures of organisms whose ancestors lived in seas that no longer exist. The volcanic chambers hold the microbial communities whose biochemistry connects them to the oldest living things on Earth. All of this is held in the dark, preserved by the conditions of the underground, protected from the erosion and the change and the disruption that the surface world is constantly subject to. The underground is the continent's archive, the record of what it has been and what has lived in it and how conditions have changed across the deep time of its existence. That archive is not complete. Much of it has been lost to geological processes, to the dissolution of soluble rock, and the deformation of ancient formations by subsequent geological activity, and the filling of passages with sediment over millions of years. What remains is a sample, not a complete record. But the sample is extraordinarily rich, and the tools for reading it are improving constantly. The story of what Australia was before humans arrived is not fully told. It is still being assembled from the fragments that the underground has preserved. The complete story would take longer than a night to tell, and longer than any single human life to fully understand. But the fragments we have are astonishing. A continent that was isolated from the rest of the world for millions of years, allowing its biology to develop in directions that the rest of the world did not take. A fauna of enormous and extraordinary animals that lived on the continent for millions of years before their disappearance. A geology of incomprehensible age that contains within it the record of conditions so ancient that the biology of the time is almost unrecognizable. An underground ecology that represents millions of years of isolated evolutionary experiment, producing organisms of breathtaking strangeness and specificity. And above all of it, the human story. The arrival of the first Australians on the shores of a continent whose megafauna had never encountered humans before. The establishment of cultural traditions whose depth and sophistication is only beginning to be understood. The development of knowledge systems that maintained accurate information about the country across 65,000 years of continuous occupation. The survival of those knowledge systems through the trauma of colonization and dispossession, and the ongoing maintenance of the relationship between the people and the country that the knowledge describes. All of that above the underground, connected to it through the caves and the aquifers, and the breathing of the limestone and the bones in the cave floors, and the knowledge that the traditional custodians carry about the underground spaces of their countries. The whole picture, the full story. The oldest continent and the oldest civilization, and the underground archive that connects them both to a past so deep that the standard measurements of human time cannot reach it. That is what Australia holds, beneath its surface and above it, and in the living traditions of the people who have been its custodians for longer than any other people have been the custodians of any other place on Earth. It is an extraordinary inheritance. It belongs to Australia and to the world. Good night from that inheritance. Good night from the underground archive. Good night from the megafauna bones in the Narakorti floors. Good night from the pale crustaceans of the Nullarbor water. Good night from the microbial communities in the volcanic chambers. Good night from the speleothems of the Sulkin and the Jenolan and the Shilago, accumulating their mineral layers in the dark, recording the climate of the surface world in a form that no storm or drought or fire can erase. Good night from the lava tubes of Undara, from the flooded passages of Mount Gambier, from the karst systems of Margaret River, from the ancient aquifers of the Pilbara. Good night from the deepest dark. Good night from the oldest country. The breath comes in, the breath goes out. The underground of Australia does what it has always done. And you do what you do in the dark. Sleep, good night, good night, good night. The hours before dawn have a quality that is different from the hours before midnight. The darkness is the same darkness in the physical sense, the same absence of photons in the same wavelengths that the eye would use to construct a visual world. But something in the quality of it changes in the small hours before the eastern horizon begins its first, barely perceptible brightening. The dark becomes somehow more complete, more final, more fully itself, as though it has settled into its deepest expression before the long process of yielding to the morning begins. The Australian underground does not have this quality. It does not have pre-dawn and post-midnight. It does not have the temporal variation that the rotation of the Earth imposes on the surface world. The dark at 3 in the morning and the dark at 3 in the afternoon are, in the deep sections of the cave systems, identical, not just similar, the same temperature, the same absence of light, the same chemical composition of the air, the same sounds of water moving slowly through passages in the rock. Time, underground, is not marked by the rotation of the Earth. It is marked by other things, by the slow growth of the speleothems, adding fractions of a millimeter per year to their mineral structures, by the equally slow evolution of the cave organisms, each generation carrying the accumulated changes of the ones before it, the population drifting genetically away from its surface relatives at the steady rate dictated by mutation and selection, by the even slower change of the cave geology, passages enlarging as the water removes more rock, chambers growing as ceilings collapse, the whole system evolving on timescales measured in millions of years. This is a different kind of time from the time that organizes the surface world. Surface time is circular, returning in its seasons and its days to the same conditions it began with. Underground time is linear. The cave of 10,000 years from now will be slightly larger and slightly different from the cave of today. The stalactites will be fractionally longer. the cave organisms will be fractionally more adapted to their environment. The record accumulated in the mineral formations will be fractionally more complete. The underground is going somewhere. It is not going there quickly, but it is going. The same is true of the knowledge about the underground. The research is accumulating. The understanding is deepening. The collaboration between scientific research and traditional knowledge is developing. The picture of what is down there is becoming clearer year by year, paper by paper, field season by field season. Australia's underground is being understood, slowly, incompletely, but genuinely and with increasing sophistication. That understanding matters. It matters because the underground of Australia is extraordinarily vulnerable to surface activities that the people conducting those activities may not know are affecting it. Mining operations that alter groundwater levels can dry out aquifer communities that have existed for millions of years. Agricultural chemicals that reach the water table can contaminate cave water systems, whose organisms have no tolerance for synthetic compounds because they evolved in environments where synthetic compounds did not exist. Climate change is altering the rainfall patterns that feed the surface water entering cave systems, potentially changing the chemistry and the temperature of cave environments in ways that the organisms living in them did not evolve to handle. The cave organisms of Australia are among the most vulnerable populations on Earth because they are so highly specialized, so completely dependent on the specific conditions of their specific environments, and so unable to move or adapt to different conditions on any timescale relevant to the rate of environmental change that is currently occurring. Their vulnerability is compounded by their invisibility. You cannot see an aquifer community from the surface. You cannot assess the health of a Nullarbor cave crustacean population without specialized knowledge and equipment. You cannot know that a species has gone extinct until someone looks for it and finds it absent. And if no one has looked recently, the extinction may go unnoticed for years or decades. The conservation of Australia's underground is therefore a scientific challenge, as well as a political and ethical one. It requires the development of baseline data about what communities exist and where, so that changes can be detected. It requires the development of monitoring protocols that can track the health of cave communities without disturbing them. It requires the application of scientific understanding to land management decisions that currently are made without any consideration of their underground consequences. And it requires the recognition that the knowledge needed to do all of this is not held exclusively by scientists. The Aboriginal communities whose traditional relationship with the country includes its underground dimensions hold knowledge that is relevant to the conservation challenge. Knowledge about the history of the underground environments and the organisms that inhabit them, and the changes that have occurred in living and cultural memory. That knowledge is not a supplement to the scientific knowledge. In some cases, it is the primary knowledge, the only record that exists of how conditions in a particular underground environment have changed over time. The cave of Narakorti holds its bones. The Nullarbor holds its crustaceans. The Pilbara holds its ancient aquifer communities. The volcanic chambers hold their microbial life. The traditional custodians of those landscapes hold their knowledge of them. The scientists hold their data and their analytical tools. The full picture of the Australian underground requires all of these, and the bringing together of all of these is one of the most important tasks in Australian natural science. It is being attempted, with all the difficulty and the misunderstanding, and the slow building of trust that any genuine collaboration between different knowledge traditions requires. It is a work in progress, not a completed achievement, but it is underway. And in the dark, the cave systems wait with the patience of geological time. The organisms go about their business. The speleothems add their fractions of a millimeter. The record accumulates. The underground is in no hurry. The underground has never been in a hurry. It was here before hurry was a concept that existed. It will be here long after the concept has been forgotten. Your own sense of hurry, if you had any when the evening began, has probably dissolved by now. The voice has been carrying you through deep time and deep dark for long enough that the urgency of the surface world has become abstract. The things that seemed important this morning are not less important for having receded. They are still there, in whatever space the daytime mind uses to store its concerns. But they are quiet now, held in suspension, waiting for the morning to reactivate them. Let them wait. The morning will come and they will be ready for it. Right now there is only the dark and the breath and the slow approach of sleep that has been building across the length of this story. The Jenolan Caves, which we visited earlier in this story, have one particular feature that deserves more attention in this deeper hour. In the oldest parts of the system, in the sections that have been forming for the longest time, there are cave formations that are not easily explained by the standard models of speleothem growth. They are formations that grew in conditions that are not currently present in the cave. Conditions that correspond to a period in the distant geological past when the environment of the cave was different from what it is today. These formations are called relict formations. They are the record of a cave that no longer exists in the form that produced them. The cave has changed around them. The hydrology has changed. The climate on the surface has changed. The chemistry of the water moving through the system has changed, but the formations remain, holding in their mineral structure the record of what the cave was before it became what it is. The relict formations of Jenolan are extraordinary windows into a past that has no other surviving record. They are samples of conditions that existed hundreds of millions of years ago in a cave environment that has since transformed completely, preserved by the same mineralizing process that produced them, held in the dark of a cave whose overall character is very different from the character of the cave that made them. They are relics. The word is appropriate. Remnants of a world that is gone, preserved by their own chemistry, waiting in the dark to tell their story to anyone with the tools to read it. The Australian underground is full of relics, not in the archaeological sense of human artifacts from past cultures, though those exist in some cave systems as well, but in the geological and biological sense. Relict formations from ancient caves, relict fauna from ancient seas, relict microbial communities from the earliest conditions of life on Earth. Relicts of what Australia was before it was what it is. This continent has always been exceptional in its capacity to preserve what is ancient. The stability of the Australian Craton, the ancient geological core that has not been significantly disturbed by plate tectonic activity for billions of years, means that features that would have been destroyed by mountain building or subduction or volcanic activity elsewhere have survived in Australia. The desert conditions of much of the interior mean that erosion is slow and preservation is good. The underground conditions of cold and dark and mineral saturation mean that biological material and geological information can be preserved across timescales that are impossible elsewhere. Australia is a natural archive. The country holds its history above ground and below it with extraordinary fidelity. The surface record is incomplete because the surface is subject to erosion and fire and the activities of organisms, including humans. But the underground record, sealed from the surface except for the slow exchange of water and gas, is more complete, more detailed, more faithfully preserved. To read the underground record of Australia is to read the full history of the continent, or as much of that history as current scientific tools can extract. It is a reading that will take generations of researchers working with increasingly sophisticated methods, and each generation will see more than the last because the tools for reading geological and biological records improve with every decade of scientific development. The readers of the underground record 100 years from now will know things about Australia's ancient past that we cannot currently even formulate questions about. They will have tools that extract information from the mineral structure of speleothems with a precision that current technology cannot approach. They will have genetic tools that can characterize the microbial communities of deep rock formations in their full complexity, mapping the metabolic diversity of the underground with a completeness that the current sampling methods cannot achieve. They will have the accumulated record of long-term monitoring programs that have tracked the cave environments across decades, providing the kind of baseline data that allows change to be detected and interpreted. They will know more, and what they know will be extraordinary. We are at the beginning of the reading. We are the generation that has established that the reading is possible, that the record exists, that the underground of Australia holds information that is worth extracting. The generations that follow will do the extracting. That is how science works. Each generation builds on the last. Each generation reads further into the record. Each generation adds to the accumulated understanding. And the underground waits, patient, dark, old, full of the record of what has been, what has lived, what has changed, and what has endured across the enormous span of geological time. The waiting is not passive. The cave is not simply holding still while science catches up with it. The geological processes that shape it continue. The organisms that inhabit it continue. The water continues to move through the passages, depositing and dissolving, adding fractions of millimeters to the mineral record, carrying the genetic material of the cave organisms through the passages as they swim and crawl and drift through the dark water. The underground is alive, not in the metaphorical sense of being rich or dynamic or interesting, though it is all of those things, but in the literal sense of containing living organisms going about the business of being alive, extracting energy from their environment and using it to maintain the organized complexity of their cells and to reproduce and to continue the ancient project of life in the dark. Life in the dark. That is what Australia's underground is. One of the largest and oldest collections of life in the dark on Earth. Life that has been in the dark for so long that it has become the dark in a sense, has become so thoroughly adapted to the absence of light that the presence of light is simply irrelevant, the way water is irrelevant to a creature that lives in air. You are in the dark too right now. The dark of your room, the dark of your closed eyes, the dark of sleep approaching. You have been in the dark for this entire story, the dark of the late hours and the dark of the voice, and the dark of the imagination that has been constructing Australian cave systems and nullable aquifers and volcanic chambers from the raw material of words. That imagination is getting tired now, not in a painful way, in the way that the body and mind get tired when they have done good work for a sustained period and are ready to let the work go and rest in what has been built. The work of this story has been the construction in your imagination of the Australian underground, the vast and patient and ancient world below the surface of the oldest continent, the world that was not made by human hands and does not need human presence to continue its business. The world that holds the record of what the continent has been in mineral and bone and living organism and the slow chemistry of ancient rock and water. That world is constructed in you now, imperfectly, incompletely, in the rough and approximate way that words can construct anything, but it is there. The pale crustaceans of the Nullarbor are there. The megafauna bones of Narakorte are there. The relict formations of Genelin are there. The lava tubes of Undara are there. The volcanic chambers with their microbial communities are there. The Pilbara aquifer with its ancient stegofauna is there. The flooded blue-lit passages of Mount Gambier are there. The Devonian reef origin caves of Chillago are there. All of them constructed in the dark of your closed eyes, waiting with the patience of geological time. That is enough. That is more than enough. That is the gift of a story well enough told that it builds a world inside you and then lets you rest in it. Rest in the Australian underground tonight, in the dark that has been dark for longer than imagination can reach, in the company of organisms that have been in the dark for longer than any story can tell, in the presence of a geological record that is patient beyond all human concepts of patience. The morning will come. It always comes, but the underground will still be there when it does. Good night from the deep dark. Good night from the pale crustaceans. Good night from the megafauna bones. Good night from the relict formations in their dark passages. Good night from the lava tubes. Good night from the volcanic chambers. Good night from the ancient aquifers. Good night from the Devonian reef limestone and the Nullarbor shallow sea limestone and the Pilbara ancient Creighton rock. Good night from the dark. Good night. The breath comes in slow and even. The breath goes out slow and even. The underground of Australia does what it has always done. The living thing in the dark go about their patient business. The speleothems add their fractions. The bones hold their record. The water moves through the rock at its geological pace. And you sleep, as you have always slept, as all your ancestors slept, in the dark that covers everything. Good night. Good night. Good night from the oldest country in the world and all the extraordinary things it holds below its ancient surface. Good night. The dark is complete. The dark is comfortable. The dark is old and patient and not afraid of anything. Good night. Good night. Rest. There is a silence in the very deep hours of the night that is related to but distinct from the silence of the Australian underground. The silence of the surface night is temporary. It is the silence between sounds, the gap in the traffic, the pause between the call of the night bird and its answer. It has within it the constant potential of sound returning, of the surface world resuming its business, of the temporary quiet being replaced by the ordinary noise of a world in motion. The silence of the deep underground is different in kind. It is not the pause between sounds. It is the absence of the conditions that produce surface sounds. No wind, because the air is still and has been still for so long that the concept of wind has no meaning in the context of the cave. No animal calls, because most of the animals that produce calls evolved in environments where sound travels through air over the distances that calls are designed to bridge, distances that caves do not provide. No weather, no traffic, no machine hum, no structural settling of buildings, no voices. What sounds exist in the deep underground are geological sounds. The drip of water onto a growing speleothem, regular as a clock, but on a geological schedule, each drop adding its microscopic increment to the mineral record. The creak and settle of rock under the enormous pressure of the overlying geology. Sounds so low in frequency that they are felt more than heard, vibrations that pass through the body of the cave and through the body of any organism inside it. The movement of water through passages in the rock, sometimes audible as a faint rushing if there is enough flow and the passage is close enough to the surface, more often silent because the flow is too slow and too diffuse to produce sound. These sounds have been the sounds of the cave for as long as the cave has existed. For the Nullarbor caves, that is 15 million years of dripping water and creaking rock and the slow movement of ancient groundwater through limestone passages. For the Jenolan caves, it is 300 million years of the same sounds, the geological sounds of a cave doing what caves do across enormous spans of time. The cave organisms that inhabit these spaces do not experience the silence the way a surface organism would experience it. For a surface organism, silence is the absence of information. The nervous systems of surface organisms are calibrated to extract information from sound, to distinguish the sounds that indicate danger or opportunity from the background noise of the world. Silence in a surface organism's environment often signals something. The predator that has stopped the birds from calling, the weather front that has silenced the insects. Surface organisms are alert to silence in ways that cave organisms are not. The cave organisms evolved in an environment where geological silence is the constant condition. They do not extract information from the absence of sound because there is always an absence of sound. Their sensory systems are calibrated to the sounds that do exist in caves. The vibrations of water movement, the chemical signals carried in the water, the mechanical vibrations produced by the movement of other organisms through the water or along the surfaces. These are the information-rich signals in the cave environment, and the cave organisms are extraordinarily sensitive to them. A blind cave fish in the groundwater of a Pilbara aquifer can detect the water displacement produced by the movement of a small crustacean several centimeters away. A cave crustacean in the Nullarbor water can follow a chemical gradient to a source of organic material across distances that would be impossible to navigate by touch alone. These are senses that surface organisms have in rudimentary form, but that have been developed in the cave organisms to a degree of precision that the surface environment never required and never would produce. The cave has made these organisms into instruments of extraordinary sensitivity for the signals that matter in the dark. It has, over millions of years of selection, turned up the volume on the senses that are useful and turned down the volume on the senses that are not, producing animals that are precisely calibrated to their particular dark and their particular chemistry and their particular geological noise. That calibration is one of the most beautiful things about cave biology. The fit between organism and environment, the precision of the adaptation, the elegance of the solution that millions of years of selection has produced for the problem of living without light. There is no waste in these organisms. Every feature serves its function in the dark. Every structure represents the evolutionary result of many generations of testing what works and discarding what does not. The cave organism is a masterwork of functional design. Not designed by intelligence, because evolution does not work by intelligence, but designed by the patient accumulation of functional change over geological time, each generation incrementally better fitted to the cave than the one before. The whole process moving toward a form that is as well suited to the dark water as any form can be. Think about what that represents. Millions of years of iterative improvement, each generation testing the design against the demands of the cave, the failures weeding out, and the successes propagating forward. The pale crustacean in the Nullarbor water is the current expression of that process, the latest iteration of a design project that has been running since before the Nullarbor plain existed in its current form, since before the sea that deposited its limestone had retreated, since before any ancestor of yours had developed the capacity to wonder about caves. That crustacean is not primitive. It is extremely sophisticated. Its sophistication is expressed in forms that are unfamiliar because they are optimized for an environment that the surface world does not provide. But sophistication is not measured by the standards of the surface world. It is measured by the fit between the organism and its environment. And the pale Nullarbor crustacean fits its environment with a precision that makes most surface organisms look like rough drafts. This reframing of what sophistication means is one of the gifts that cave biology offers to the broader understanding of life. The cave organism is not a reduced version of the surface organism. It is a different version, optimized for different conditions. The absence of eyes is not a deficiency. It is an appropriate response to an environment where eyes provide no benefit. The pale coloration is not a pathology. It is the logical result of millions of years of selection in which pigment production provides no advantage and costs metabolic resources that could be better spent on other functions. The cave teaches us that evolution does not move toward complexity for its own sake. It moves toward fit, toward the form that works best in the specific conditions of the specific environment. In an environment where eyes are useless, the eye disappears. In an environment where chemosensory capabilities are crucial, those capabilities are developed to extraordinary degrees. The cave produces organisms that are perfectly fit to the cave, and from the cave's perspective, they are masterworks. From the cave's perspective, as if the cave had a perspective. The cave does not have a perspective. It has conditions. Conditions that select among the variations that arise in the populations of organisms that inhabit it, rewarding some variations and eliminating others, across timescales measured in millions of years. The result, viewed from the outside with the appreciation that the biological sciences have developed for evolutionary process, looks like design, looks like the work of a master craftsperson fitting the organism to its environment with extraordinary precision. But it is just time, just the patient operation of selection across an environment that is stable enough and isolated enough to allow the long work of adaptation to reach a result that no shorter process could produce. The Australian underground, with its extraordinary age and its extraordinary isolation, has provided some of the most complete examples of this process on Earth. The organisms it has produced are among the most specifically adapted, the most precisely fitted to their environments, of any organisms currently alive. They are not found elsewhere because their adaptation is so specific that nowhere else provides the conditions they require. They are here, in the dark below the surface of the oldest continent, being exactly what they have been shaped to be, across more time than any human civilization has existed. That is worth knowing about, worth holding in the imagination, even in the imagination of the late hours, even as sleep closes around the knowledge and carries it down into the substrate of understanding. the Narakot cave floors have one more thing to offer. We visited them earlier in the context of the megafauna bones, the record of what lived above the cave in the geological and biological recent past. But the cave floors of Narakoti also contain something that the bones of the megafauna overlay and predate. Beneath the megafauna bones, in layers that accumulated before the era of the giant animals, there are older deposits. Deposits from a time when the fauna of Australia was different in character from both the modern fauna and the megafauna. From a time so deep in the Australian fossil record that the lineages of the animals represented in those older deposits are unfamiliar, not related to any currently living group in the way that the megafauna are recognizably related to the modern marsupials and reptiles and birds. The oldest deposits in the Narakote floors are from the Pleistocene, the geological epoch that began approximately 2.5 million years ago and ended 12,000 years ago with the retreat of the last Ice Age glaciers. The bones from the oldest Pleistocene layers of the Narakot floors include species that have no living descendants, groups that did not survive into the present even in the reduced form of the surviving megafauna. They are more completely gone than the megafauna. They are animals that exist only in the fossil record, known only from bones in cave floors and other depositional environments. Their biology reconstructed from what the bones tell us about their size and movement and diet. These animals were part of Australia before the animals we think of as distinctively Australian took their current forms, before the kangaroos evolved their distinctive mode of locomotion, before the wombats developed their compact fossorial body plan, before the modern fauna of Australia settled into the ecological roles it currently occupies. The Narakote caves hold them in their oldest layers, waiting in the dark for the researchers who have developed the tools to read their record. The tools have been improving for decades. The researchers have been working for decades. The picture of what lived in Australia in the deep Pleistocene is becoming clearer, and it is a picture that contains surprises. Animals whose ecological roles have no current parallel in Australia. Fauna communities that process the vegetation of the ancient continent in ways that no current herbivore does. Predators that occupied niches now empty, that are filled in no other mammalian fauna of the period, because Australia's isolation produced a marsupial fauna with no living equivalent anywhere on Earth. The cave floors hold all of it, the oldest layers and the newest, the record of what Australia was across 2.5 million years of biological time, all in the dark below the surface of the South Australian countryside. The countryside above Narakorta is agricultural, farms and vineyards and roads and towns, the ordinary surface of a region that has been modified by human activity across 2 centuries of intensive land use. Below it, in the cave floors, the record of a world before agriculture, before Europeans, before Aboriginal Australians, before any human foot touched Australian soil. Before any human mind formulated the concept of Australia. The cave does not judge the contrast. The cave has been below the surface for 15 million years. The 2 centuries of intensive agriculture above it are a brief interruption in the long quiet of its existence. The bones will be there long after the farms are gone. The record will persist long after the human activity that currently overlies it has run its course and been replaced by whatever comes next. The geological patience of the cave is not indifference. It is simply the operation of a timescale so large that the activities of the surface world, however significant they seem from inside those activities, register as barely perceptible ripples in the long geological record. Your own activities today, whatever they were, whatever urgency they carried, whatever concerns they generated, are similarly scaled against the deep time of the Australian underground. Not diminished, not made unimportant, simply scaled. Placed in a context in which the proportions are accurate rather than the distorted proportions that the immediacy of daily life imposes. In that accurate scaling, the things that matter most to you are still the things that matter most to you. But the weight of urgency, the pressure of everything that demands immediate attention is slightly reduced. The cave does not think your deadline is a geological event. The cave does not register your anxiety. The cave is simply the cave, old and dark and indifferent, doing what it has always done. And in the middle of the night, in the dark, that indifference is comforting. The cave will be the cave whether you sleep or not. The bones will be in the Narakote floors, whether you're anxious or at rest. The pale crustaceans will be in the Nullarbor water, whether you remember them tomorrow or forget them entirely. The underground does not need your attention to continue its work. Sleep, the work continues without you. The dark holds everything. The geological record accumulates its next fraction. The cave organisms go about their extraordinary business, and you rest in the dark of your own small corner of the surface world, held by the same gravity that holds the cave and the bones and the organisms and the record, all of it together on the same ancient, patient, indifferent, extraordinary planet. Good night. Good night from the planet. Good night from the deep time. Good night from the living dark below the oldest surface on Earth. Good night. The breath is very slow now. The body is heavy and still. The mind is at the edge of a place where thinking stops and the deeper processes take over. Let it go there. The underground of Australia will be exactly as it is when you return to the surface in the morning. Old, dark, full, patient. The pale crustaceans will still be in the Nullarbor water. The megafauna bones will still be in the Narakote floors. The speleothems will have grown by a fraction too small to measure. The microbial communities in the volcanic chambers will have continued their slow camellithotrophy. The ancient aquifer organisms of the Pilbara will have continued whatever it is they do in the dark of the old Pilbara rock. Everything will be exactly as it was. And you will be exactly as you are, rested and whole and carrying into your morning the quiet knowledge of what is down there below the surface of the oldest continent. The knowledge will be there, settled in you, not loud, not urgent, just there in the substrate of your understanding, part of the ground that everything else stands on. Good night from the ground, good night from everything it holds. Good night from the dark that has been dark longer than you can imagine. Good night. Good night, good night. The underground waits, you sleep. Good night. The hours of deep night have no consensus on what they mean. Different traditions assign different significances to them. Some say the hours before dawn are the hours when the boundary between the ordinary world and other dimensions is thinnest, when the things that do not usually communicate with the surface world are more accessible. Some say the deep hours are simply the hours when the body is most completely at rest, when the biological processes of restoration and consolidation operate most efficiently without the interruption of consciousness and its demands. Some say the deep hours are the hours of the ancestors, when the accumulated weight of everything that has come before presses most closely against the present. The underground of Australia does not have an opinion on any of these interpretations. The underground is simply the underground, going about its geological and biological business with the indifference that deep time produces in anything that has been doing the same thing for long enough. But the underground is there, in all those hours and all the hours before them, and all the hours to come after, dark and patient and full of the record of the continent, full of the organisms that have adapted to its conditions across millions of years, full of the waters that carry the chemical signatures of a geological past so remote that its biology has no living representative on the surface, full of the mineral formations that have been growing grain by grain in the dark since before the current climate regime of the continent was established. You have been in the presence of all of that tonight, in whatever way a voice in the dark and an imagination constructing images from words can constitute presence. You have been in the Nullarbor and the Narakurti and the Janalan and the Undara and the Chillago and the Buchan and the Carnarvon and the Pilbara and the volcanic chambers of the southeast and the flooded blue passages of Mount Gambier. You have been in the Devonian Reef and the shallow Eocene Sea and the ancient Tethys Ocean, whose crustacean refugees are still in the groundwater of the limestone country. You have been in a very large and very old and very dark place. And it has been, in the end, comfortable. The dark of the Australian underground is not threatening. It is simply what it is. Old and indifferent and full of life going about its patient business. The same qualities that make the deep underground inhospitable to surface life make it comfortable for the organisms that have adapted to it. The same qualities that make it strange to a surface organism make it exactly right for the organisms that evolved there. From inside the cave is not strange, it is home. The pale crustaceans do not experience the Nullarbor water as a strange or challenging environment. They experience it as the only environment, the environment their biology was shaped to inhabit, the environment that provides everything they need in the proportions that their metabolism is calibrated to use. They are not struggling against the dark. They are not surviving in spite of the darkness. They are thriving in it, doing exactly what they evolved to do in exactly the conditions they evolved to do it in. That is a profound kind of belonging. The belonging of an organism to its environment, when the relationship between organism and environment has been refined across millions of years to a precision that cannot be improved upon. A belonging so complete that separation from the environment is not merely uncomfortable but impossible. The cave crustacean cannot live on the surface. The surface is not its environment. The cave is. Most surface organisms have a more flexible relationship with their environments. Humans in particular have developed the capacity to inhabit an extraordinary range of conditions through the application of technology and knowledge, carrying our preferred conditions with us into environments that would otherwise be hostile. We can live in the Arctic and in the desert and in cities and on high altitude mountains and at the bottom of the sea in submarines. We are the most habitat generalist large organisms on Earth. But beneath the surface of Australia, in the dark of the ancient limestone and the volcanic rock and the deep aquifers, there are organisms for whom that generalism is simply not a category. They did not evolve to be flexible. They evolved to be perfectly fitted. And the fitting is so complete after so many millions of years that the fit is indistinguishable from belonging. What would it be like to belong to a place that completely, to a darkness that thoroughly, to an environment whose conditions you are calibrated to with a precision that makes the concept of another environment meaningless? We cannot know from the inside. We can observe it from the outside and wonder at it. We can recognize it as one of the most extraordinary results of the evolutionary process. This production of perfect belonging through the long work of selection across geological time. The wonder of it is available to anyone who knows it exists. You know it now. The pale crustaceans of the Nullarbor are in your knowledge now, belonging to their darkness with a completeness that surface organisms can observe but never fully participate in. That knowledge is yours to keep, light enough to carry, real enough to mean something, true enough to sustain the small shift in perspective that comes from understanding just how large and how old and how full the world is, above the surface and below it. The dark of the deep night is lifting somewhere. The earth has turned enough that the eastern sky, wherever it is relative to you, has passed the point of its deepest dark and begun the infinitesimally slow process of brightening towards the false dawn. You cannot see it from wherever you are. The room is still dark, the night is still complete. But the process has begun in that part of the atmosphere above the eastern horizon. Photons from a sun still below the horizon beginning to scatter off the upper atmosphere in the first suggestion of the coming day. The underground of Australia is unaffected by this process. The eastern horizon means nothing to the organisms in the Nullarbor water. The approach of dawn changes nothing in the volcanic chambers. The bones in the Naracoorte floors do not stir. The speleothems continue their slow growth at the same rate they maintained through the deepest dark of the night. The surface world turns, the underground waits. You are a surface organism. You are turning with the world, moving toward the morning without knowing it, your body already beginning the extremely slow adjustments of sleep architecture that correspond to the approach of the waking period. The deepest sleep phases are behind you now. The lighter phases are coming. Consciousness will return gradually as the morning arrives. Not as a sudden event, but as a slow restoration, the way light returns to the sky, imperceptibly at first, then unmistakably, then completely. Let that process happen on its own schedule. There is nothing required of you to make morning come. The earth turns without assistance. The biological processes that move you from deep sleep toward waking operate without your conscious engagement. Everything's going where it is going. You can simply be present in whatever phase of the process you are currently in and trust the process to do what it does. The Australian underground trusts the process, if trust is a concept that applies. The geological processes that shape it will continue. The biological processes that maintain its inhabitants will continue. The chemical reactions that produce its mineral formations will continue. The slow movement of ancient water through ancient rock will continue. Everything will continue because that is what geological processes do. They continue across the timescales that make human concepts of beginning and ending inadequate. You will continue to. Morning will come and you will wake and the day will proceed and the concerns of the surface world will reassert themselves. The underground of Australia will recede to the background of your awareness, where it will remain as a quiet knowledge, a depth beneath the surface world that you can access when the surface world seems too loud and too urgent and too present. The underground is a resource for the imagination, a place to go when the surface is too much. A reminder that the world is larger than the surface. that beneath whatever is immediately pressing there is a depth that goes down and down through limestone and basalt and ancient craton rock to a core of molten iron that has been turning slowly since the planet formed, 4.5 billion years ago. The depth is always there. The dark below the surface is always there. The pale crustaceans are always in the Nullarbor water, going about their patient business. The megafauna bones are always in the Naracoorte floors. The microbial communities are always in their volcanic chambers. The underground does not require your attention to maintain itself, but your attention, directed to it, can provide a perspective on the surface world that makes the surface world more bearable, more proportional, more clearly itself, neither more nor less than it is. The surface world is enormous and complicated and full of urgency that feels greater than it is. And beneath it, in the dark, the oldest things on Earth are going about their business with the patience of geological time, indifferent to the urgency, indifferent to the complication, indifferent to the enormity of the surface and everything that happens in it. That indifference is not cold, it is simply accurate. The underground does not judge the surface. It is simply not the surface. It is something else, something older, something more patient, something that does not need the surface to validate it or acknowledge it or pay attention to it. It is simply there, as it has always been, as it will always be. Good night from the thing that has always been there. Good night from the dark below the dark. Good night from the patience that makes all other patience look brief. Good night from the organisms that have been in the dark longer than your species has existed. Good night from the mineral record that has been growing longer than any story can be told. Good night from the ancient waters carrying the chemical memory of seas that no longer exist. Good night from Australia and from what it holds below its surface, and from the Aboriginal communities whose knowledge of that underground extends across a span of time that scientific research is still learning to appreciate and work with. Good night from all of it. Good night. The dark is complete. The breath is slow. The underground of Australia is exactly what it has always been, and you are sleeping, or very nearly. Good night. Good night, good night from the deep. Something worth adding to the story before the final silence. The word underground itself carries a quality that the word cave does not quite capture. Cave implies a specific and bounded space, a room in the rock with walls and a ceiling and an entrance. Underground implies something larger, something continuous, something that is beneath the entire surface, not just beneath this particular hillside or this particular stretch of limestone plain. Australia is underground everywhere. Beneath the red sand of the Simpson Desert, beneath the salt lakes of the Eyre Basin, beneath the dense wet forests of Tasmania, beneath the shallow shelf of the continental margin, beneath every surface expression of the continent, there is an underground. Layers of rock and water and geological history going down through the sedimentary layers of the surface and through the ancient basement rock below them and into the slowly convecting mantle that the basement rock floats on, all the way down to the iron core that generates the magnetic field that the compass points toward, and that the birds navigate by, and that the cave organisms deep in their dark are responding to in ways that nobody has yet fully characterized. The underground of Australia is the continent itself, viewed from below. It is the depth of the place rather than its surface. It is what the surface rests on, what the surface is made of, what the surface expresses in its topography and its soils and its rivers and its biology. To know the underground is to know the continent in its full thickness, not just as a two-dimensional surface, but as a three-dimensional body of rock and water and history and life, extending from the tallest point of its topography to the deepest point of its geological structure. That body, three-dimensional and ancient and full, is what we have been traveling through tonight in the imagination, guided by the voice in the dark and the images that the voice constructs. It is a large body, a very old body, a body that has been accumulating its complexity for longer than any human story can encompass. And yet, somehow, in the small hours of the night, in the dark of your room or wherever you are, the entire thing has been present. The Nullarbor crustaceans and the Naracoorte bones and the Mount Gambier blue water and the Pilbara ancient aquifer and the volcanic chambers of the southeast and the Jenolan relic formations and the Buchan speleothems and the Undara lava tubes. All of it present in the space of a night story, in the imagination that the voice has been building for you across the hours. That is the gift of story, that it can contain, in the small space of a human listening, things that are too large for any physical space to hold. The entire underground of Australia compressed into a night, the geological timescale of the continent, passing in the time it takes to breathe in and breathe out. The millions of years of adaptation that produce the cave organisms, present in the few seconds it takes to describe them. Story is the most efficient compression algorithm that human culture has developed. It takes enormous things and makes them small enough to carry. It takes deep time and makes it available to surface organisms with short lifetimes. It takes invisible worlds and makes them visible in the imagination. The underground of Australia is now visible to you in the imagination. Imperfectly, incompletely, but genuinely. You know that it is there, that it is old, that it is full of life and record and history, that it is connected to the surface world through the cave entrances and the groundwater and the cave breath and the pitfall traps and the traditional knowledge of the people whose relationship with the country extends below its surface. That knowledge is real and it is yours, and you can take it with you into the morning. The cave crustaceans will be in the dark water when you wake. The Naracoorte bones will be in their floor. The speleothems will be fractionally longer. The microbial communities will have continued their chemolithotrophy. The ancient aquifer organisms will have continued whatever extraordinary existence they maintain in the old Pilbara rock. The underground will be exactly as it is. You will be rested and whole and carrying something true. Good night. Good night from the underground that does not sleep. Good night from the organisms that have never known morning. Good night from the rock that has been old since before the concept of old was a concept. Good night from Australia, the oldest continent, holding in its dark interior the record of what it has been and what has lived in it since the beginning. Good night. The breath goes in, the breath goes out, the earth turns, the underground waits. Good night, good night, good night, sleep. There is a last thing the underground offers to the surface world, and it is not geological, and it is not biological, and it is not archaeological. It is simply perspective. The surface world is loud and urgent and full of things that demand immediate attention. The underground is none of those things. The underground is slow and dark and patient, operating on timescales that make the urgency of the surface world look like a brief flicker. At the edge of something enormous, the underground does not hurry. The underground has never hurried. The underground will still be here, doing what it does long after whatever is urgent on the surface today has resolved itself one way or another. That perspective is available to anyone who thinks about the underground and holds it in the imagination alongside the surface world. Not to diminish the surface world, not to make its concerns seem trivial, but to scale them accurately, to place them in the context of a world that extends below the surface into depths of time and space that the surface world cannot perceive, but that are always there, underneath everything. The Australian underground is beneath you now, wherever you are. Not physically beneath your body, which is probably somewhere on the surface of a continent far from Australia, but beneath you in the conceptual sense, in the sense that the world has depth below its surface, and that depth is old and dark and full, and that knowing it is there changes the way the surface looks. The surface looks smaller. Not diminished, but more accurately scaled, more clearly itself. A thin, bright, urgent layer on the surface of something vast. A layer where consciousness lives and urgency operates and story gets told. A layer that is real and important, and the only layer that most of us will ever directly inhabit. But a layer, nonetheless, resting on the depth below it. The depth is there. The underground of Australia is there. The pale crustaceans are in the Nullarbor water. The bones are in the Narracoordy floors. The speleothems are growing fractionally in the dark of every limestone cave on the continent. The microbial communities are metabolizing the mineral energy of the ancient volcanic rock. The ancient aquifer organisms are in the deep groundwater of the Pilbara, doing what they have been doing for millions of years. All of it there, all of it continuous. All of it patient with a patience that makes sleep look brief. Sleep now. The patience is contagious if you let it be. The slowness of the underground can slow the surface mind just a little, just enough. The dark of the underground can deepen the dark of the room just enough to make sleep more complete. Let the underground slow you. Let the ancient dark deepen your own dark. Let the patience of the geological reach into your body and your mind and help them find the rest that the surface world makes difficult, but the underground makes look easy. The underground has been resting in its own way for billions of years. You can rest for a few hours. Good night. Good night from the deepest thing on earth. Good night from the oldest dark. Good night from the life that has been in the dark since before light was a concept that any living thing had developed the capacity to perceive. Good night. The breath comes in and goes out and comes in. The underground waits. You sleep. Good night from Australia. Good night. There is nothing more to say. The story has done what a story can do. It has carried you from the surface world into the underground and back again, through caves and aquifers and lava tubes and ancient rock chambers and the deep groundwater of the oldest continent on Earth. It has introduced you to organisms that have been in the dark longer than your species has existed. It has taken you into a timescale that makes a human lifetime look like the briefest possible event. It has given you the perspective of the underground to hold alongside the perspective of the surface, so that the surface world looks different for having seen what is beneath it. The surface world is bright and loud and complex and full of the demands of conscious life. The underground is dark and slow and patient and full of the extraordinary results of millions of years of isolated adaptation. Both are real. Both are part of the same planet. Both are part of the same story. You are a surface organism, but you have been underground tonight. in the imagination, in the company of the things that live there, and have lived there for longer than imagination can easily reach. Take that with you. Good night. Good night, sleep. Good night from the dark. Good night from everything it holds. Good night. The underground of Australia has been waiting in the dark since before any voice could name it. It will be waiting long after every voice has gone quiet. In that patient waiting, there is something close to peace. The peace of a world that does not need acknowledgement to continue, that does not need attention to persist, that does not need mourning to have meaning. It is enough to know it is there. Good night.